In a world where data is at the heart of every decision, harnessing its potential has never been more crucial. Snowflake, the leading cloud data platform, and Amazon Web Services, the world's most comprehensive and trusted cloud provider, have joined forces to revolutionize the way organizations manage, analyze, and derive insights from their data. This course is designed to equip you with the expertise and know how to leverage the seamless integration of Snowflake with AWS. We will explore a plethora of topics that will elevate your data management and analytics skills to a new height. This is the entire roadmap of the course. So we'll start with the basic introduction of Snowflake. Then we will move towards the core concepts like Snowflake tables, Snowflake views, partitioning and clustering in Snowflake, data loading and ingestion, roles in Snowflake, streams in Snowflake, Snowflake with Python and AWS Glue, and then finally we will see the real-time data streaming with Kafka on Snowflake. Hey, welcome back. In this video, we are going to talk about how you can set up a Snowflake trial account. Firstly, open your web browser and in your web browser type Snowflake trial account and click the first link that appears. Once you land on this page, just fill out the form that you see on the screen. Make sure that you enter a valid email address because afterwards you will have to verify it and then click continue. From here, select the standard Snowflake edition, and for the cloud provider, you have to select AWS. And once you do that, select a suitable region, and it must be similar to or close to the region of your AWS account. And then simply click Get Started. Upon clicking, you will get a verification email on your provided email address, and once you verify it, set up your username and password, and then you will be good to go. And thus, your Snowflake account will be created and will be ready to use. Welcome back. In this video, we are going to talk about how you can create different type of tables in Snowflake. By the end of this video, you would have learned how to create a database in Snowflake, how to create a schema within a database, and how to create different types of tables within a schema in Snowflake. We will start by creating a worksheet, and for that, click Worksheet button, and you can also give a name to your worksheet. After giving a suitable name, you will have the workspace where we will start writing the SQL commands. Firstly, I will switch the role to sysadmin and make sure that you create all the databases and schemas in the sysadmin role and not in the account admin role. After changing the role, I will create a database called e-commerce DB inside which all the tables will be created. Run the query and you will see that your database e-commerce has been successfully created in the databases. Next, I will create a schema called e-commerce_live inside the database that we just created. Run the query and your schema will be created inside the e-commerce DB. Now, I will use this schema to create different tables inside it. In order to create tables in Snowflake and storing data in it, a warehouse is needed. So, I am going to use a predefined Snowflake warehouse called compute.sh. Now, we will actually create a table. So, I am going to write this query in which I am going to create or replace the table. The name of the table is line item, and I am creating the table by selecting the data from another table which is already present in Snowflake predefined database table called tpch_sf 1000. Since the result is limited to 10,000, so upon running, the line item table will be created with 10,000 rows. Similarly, we will create order table and we are going to copy the data from the Snowflake sample data database. Upon running the query, your orders table will be created. Once again, we will use the schema in which we created the tables. As we have already discussed that all the tables created in Snowflake are by default temporary tables. So we are going to create a permanent table for orders to copy our data in it. Now, we will try to convert this permanent table to a transient table. But the most important question is, why would you ever want to do this? The only reason for converting a permanent table to a transient table is to avoid the cost associated with the fail-safe and recovery. As I have already mentioned that permanent tables have fail-safe and time travel automatically enabled, which is the main difference between the permanent and the transient tables. So if you want to avoid the cost of time travel and fail-safe and you don't want to keep the table for so long, That's when you convert a permanent table to a transient table, which is done by creating a transient table and copying all the data of the permanent table to the transient table. After copying the data from the permanent table to the transient table, simply drop the permanent table and you will be left with the transient orders table. And then you can simply rename the new transient table and give it the name which was of the permanent table that was previously present. And this is all about databases, schemas, tables, creating the tables and converting them from one type to another. That's all for this video. I'll see you in the next one. Welcome back. In this video, we are going to explore the different types of views in Snowflake. Views plays a crucial role in simplifying the data access, enhancing data security, and promoting data sharing with organizations. Before we get into the types of views, let's quickly see what a view is in Snowflake. So, a view is a virtual table that does not physically store data but represents a result set of a query on one or more tables. It acts as a lens through which you can access specific subsets of data or present complex queries as a simple and reusable object. There are three main types of views in Snowflake: simple view, materialized view, and secured view. So, a simple view is a basic virtual table created from a single select statement. It can include columns from one or more underlying tables. This type of view is most commonly used for simplifying complex queries or hiding the sensitive data. So the next type of view is the materialized view. A materialized view is a pre-computed, physically stored version of a query result. It's useful for queries that involve large data sets and complex computations. Materialized views improve query performance by reducing the need to recompute the same data repeatedly. Then we have the secured view. A secured view is designed to control access to sensitive data in your Snowflake environment. It allows you to restrict the visibility of certain columns, rows, or entire tables for specific users or roles. Secure views are essential for enforcing data privacy and security policies. Welcome back. In this video, we are going to see how you can create different types of views in Snowflake. Let's go to Snowflake, and after creating a new notebook, we will start by creating a new warehouse. I am going to call it prod_Excel, and the size of the warehouse is going to be extra large. You can select any other size that you want. Then I will select the database and the schema into which I want to create the views for the present tables. We will start by creating a view for the orders table in which we are going to add only those orders where the priority is urgent, and all the data will be stored in the view. Run the query and your view with urgent orders will be created. Let's have a look at the view by selecting the record from the view, and we are going to limit the rows to 10. Let's run it, and you can see that the view seems fine for now with all the data. Next, I will create a materialized view. The materialized view persists the data on your disk. Mostly, you will create a materialized view only if it is going to contain an aggregated or transformed data. Here, I am creating a materialized view called aggregated orders, inside which you have an aggregate SQL statement which is counting the number of orders and displaying the order status and date of only the urgent orders. Once your view is created, have a look at it by running a select query and limiting the number of rows to 10. Upon executing the query, you will have the view containing the count and the order status and date of orders. Now, I will create a secured materialized view in the same way I created a materialized view. I am going to use the secure keyword instead of materialize with the view name, and I am going to view the view now. I will add a clustering key to both of my views. A clustering key is a subset of columns in a table that explicitly designed to co-locate the data in the table. In the same micropartition, I will alter both views and cluster it on the basis of a particular column like order date. You can verify this by navigating to your database and inside the view, hover over each of the view to see its type, and this is how you can create different types of views in Snowflake. That's all for this video. I'll see you in the next one. Welcome back. In this video, we are going to have a look at how you can create micropartitions and clustering keys in Snowflake. In this video, you will learn how to view the micropartitions of each table, how to view the clustering keys of each table, and how to assign different clustering keys to each of your table. In this video, I am going to use this schema to perform further operations. There are two ways of viewing the clustering information in Snowflake. First is to use the built-in system functions. So any function that has a system $sign is a built-in function, and clustering underscore information is going to give us clustering information about the table line item. So the clustering information tells me that this table has been clustered by using the column L underscore ship date. The next parameter tells me that this table has 10,336 micropartitions. The parameter total constant micropartition count is the number of micropartitions that will not have a significant impact as a result of reclustering. Reclustering, as the name suggests, is the process of clustering your table when the data arrives. So, for example, you have a table and you have 5 micropartitions at the table. New batches of data are arriving and being ingested into this table. Now, what happens is that Snowflake will try to identify which chunk of this new patch of data goes into which micropartition. As a result of this, some of the micropartitions will need to be reclustered. But there will be some micropartitions which will remain untouched, so the constant micropartition will remain as it is. We can also view the table using the wildcard operator. So I am going to write show tables like line. So it is going to show me all the table that has line in its name, and it is going to give me information about the line item. Next, I will create a new warehouse of the size extra large because I am going to need this new warehouse for the particular role in order to display clustering. Then we will use this warehouse. Then we are going to display the table line item, and we are going to limit the number of records to 200,000. And then we will move to view the query history. Click on query profile, and then from there we will have a look at the query statistics. Here you can see that this query has scanned a total of 13 partitions, and the total partitions were 10,336. The bytes scanned are 9.82 GB. In order to avoid the query from fetching data from the cache, I am going to set use cache result flag to false in order to avoid getting results from the cache. Now, once again, we will view the line item table, but this time we are going to view only those rows where the L underscore shift date is 1/12/1998. I will limit the number of rows to 10,000. And then I will view the query profile for this particular query. Here you will see that the number of scan partitions is 1, total number of partition is 10,336, and the bytes scanned are 11.06 MB, and the cached result is 100%. Now I will modify this query a little bit, and instead of one date, I am going to define it 2 date to get the records from the line items table. Upon viewing the query profile, you will see that again the scan partition is 1, the total number of partition is the same, but this time the number of bytes scanned is 43.23 MB. Now I am going to view the clustering information of another table called part sub table, and it has a clustering key of ps underscore sub key. Upon running, you will see the clustering information including the total partition count, total constant partition count, average overlay, etc. Now I am going to run another query in which I will select the total number of records and count the distinct supply keys from the table parts up, and then upon running, I will get the unique supply keys for the table. Here you can see that there are a total of 800 million records, out of which 10 million supply keys are unique. Now I will switch the schema to e-commerce underscore live. Inside the schema e-commerce underscore live, I'll create a new table called customers, and I am going to copy the data in it from the Snowflake sample data table customer. Similarly, I will create 5 new tables inside the schema called nation, part, part sub, region, and supplier, and I am going to copy the data from the sample data database respective table. Upon running, all the tables will be created, but once you hover over all the created tables, you will see that the clustering key has not been copied into them. So now I will explicitly add clustering key into each of the table. I will copy the above commands and then I am going to add the clustering key into each of these tables by using the command cluster by and defining the column name by looking at the table inside the Snowflake sample data database. Now you can see that for the tables for which you defined the clustering key have been recreated with the clustering key in it. And this is how you can view the micro partitions in your table and create different types of clustering keys for each table. And that's all for this video. I'll see you in the next one. Welcome back. In this video, you will learn how to create an integration object to connect Snowflake with the AWS S3 bucket. The process of data ingestion in Snowflake is broken down into different steps. The first step is to create an IAM role in your AWS account so that Snowflake can access the data in the S3 bucket. Next, you have to create a bucket in the AWS and then upload the sample files into the bucket. And in the third step, we will create an integration object for Snowflake and AWS authentication by using the account admin role. So let's start by creating an IAM role in the AWS. I'm gonna go to my AWS account and in the search bar type IAM, click on it and you will land on a page that looks like this. Click on roles from the left navigation menu and then click create role. For the trusted entity type, select AWS account and scroll down and make sure that you click the require external ID option. Now temporarily, I'll add a random access ID, so I'm going to provide 5 zeros to it. And after that, we will update it later on. And then click on next. Now we have to give permissions to this role, right? So we have to allow Snowflake to read the data from the S3 bucket. So in this case, you have to type S3 and hit enter. And from the available options, you have to select Amazon S3 full access. And then click on next. Now let's give a meaningful name to your role. So I'm going to call it Snowflake AWS role. And in the description, I'm gonna say access for Snowflake. Leave everything as it is and click on create role. So we have created a role for Snowflake to access the AWS. For the next step, which is to create a bucket, type S3 in the search bar and click the first option that appears. From here, you have to click create bucket. Here, provide a meaningful name to your bucket and then uncheck the box that says block all public access. After that, you will acknowledge by clicking a checkbox that you are aware of the consequences for doing so. Leave everything as it is and then simply click create bucket. One thing to remember is that your buckets region and the Snowflake region should be the same. So once our bucket is created, we'll go ahead and create different folders in it. So the first folder that I'm going to create, I'm going to call it e-commerce_dev. And then once that folder is created, then inside that folder, I'm going to create another folder and I'll call it line item. Once the line item folder is created, I'm going to go inside it and then I'm going to create 3 different folders for it, which are line item underscore CSV, line item underscore JSON, and line item underscore Parquet. And once all 3 folders are created, I am going to move into the line item underscore CSV file. And inside that, I am going to upload my CSV file that I am going to use in this video. And similarly, I am going to upload the files in the line item underscore JSON and line item underscore Parquet folders as well. Once all the data has been uploaded, now go to your Snowflake account. And the first thing that I'm going to do is use the role account admin. This is because integration objects cannot be created using a role other than the account admin role. Any development or engineering task must be performed using a known account admin role. So you cannot be a sysadmin or use any custom role and create an integration object. So you must be using the account admin role in order to create the integration object. Now I'll go ahead and create a storage integration object. The syntax is really simple. You have to write create or replace a storage integration and then provide a name to your integration object. In this case, it is AWS underscore SF underscore data. Type is external stage because the storage location is external, which is AWS S3 bucket. Storage provider is S3. For the storage allowed location, you have to provide your bucket name. So you can either copy it from the AWS or you can write it on your own. And the next thing we have to provide is the storage AWS role ARN. And for that, you have to go back to your AWS account. And for the role that you have just created, click on it and you will see ARN link. Copy this and then go back to your Snowflake and paste it here. By providing a link to the entire S3 bucket to the storage allowed location, we are granting it access to the entire S3 bucket. Okay, so I forgot to add the double slash, add it here. And once you run it, you will see that your AWS underscore SF underscore data storage integration object will be created. Let's now type the next command, which is describe the integration, and after that we'll provide the name of our integration object. So if I run this command, you will see something like this. So the two values that you need to fetch from here are row number 5 and row number 7. Okay, so let's just copy the AWS IAM user ARN. Then I'm gonna go back to my AWS account, click on the role that we just created and click on trust relationships. From there, you have to click edit trust policy. And the ARN that you have just copied needs to be added here. Now we have to add the external ID. Go back to your Snowflake and copy the storage AWS external ID and then come back to your AWS account and then paste it in place of external ID. So now what we have done is we have created a role in the AWS. We have created a new bucket and uploaded our data into the bucket. And then we have created an integration object and granted it access to the S3 bucket. And by editing the trust policy, we are authenticating the Snowflake to access the data present inside the S3 bucket in AWS. That's all for this video. I'll see you in the next one, in which we will ingest the data. Welcome back. In this video, you will learn how to ingest a CSV file from your S3 bucket to Snowflake account. Now that we have updated the IAM role that we created in order for Snowflake to access the S3 bucket, let's move on to the next step now. First of all, I would like you guys to switch to the role sysadmin and create a new schema inside the database e-commerce underscore DBs. For that, we will first use the database e-commerce underscore DB, and then I'm going to create a schema called e-commerce underscore dev. Let's run it, and our schema has been successfully created. Now I want you guys to create an empty line item table. This is because we are going to ingest the data from our S3 bucket into this empty line item table. So we are gonna ingest the data from the line item underscore CSV folder. All these files will be available in the resources. So now let's create the empty line item table. I'm gonna say create or replace table line item, and I'm going to cluster it by L underscore shifted. And the cluster key should be the same as the one present inside the schema e-commerce underscore live. And I'm going to select the data from the schema e-commerce underscore live and its table line item. Let's run it and you will see that your table has been successfully created. Since we limit the number of rows to 1, so it means that this table currently has 1 row. So in order to correct it, I am going to truncate the table line item. So now we have the empty table here. Okay, I couldn't find the table. So let me first use the newly created schema. So I'm going to write use schema e-commerce underscore db dot e-commerce underscore dev. And then once again, I am going to run the create or replace table line item command to create the table inside the e-commerce underscore dev schema. And once this is done, once again, I am going to run the truncate command. The next thing that we need to do is to create a file format. Now, a file format is basically a set of rules which has a name and tells the Snowflake what is the file format that is being ingested into the table. So once we create this file format, we are going to use this name at the time of creating the stage object. Inside this file format, we have a bunch of parameters. Firstly, you have to define the type, which is going to be CSV in this case. Compression is auto, meaning auto detect. Then you have to define the field delimiter, record delimiter, and the skip header is set to true. And then there are a bunch of other parameters as well. Let's run this and you will see that your file format has been successfully created by the name CSV load format. Once your file format is created, the next step is to create a staging table. So typically every table has its own stage which refers to the specific location in the S3 bucket. Okay, so we are going to create the stage by using the command create stage. I am going to call it stage underscore line item underscore CSV underscore dev. defining that it is going to be a CSV file stage for the table line item. Then the next thing is to define the storage integration, and this is going to be the integration object that we created in the previous video, whose name was AWS underscore SF underscore data. And the next thing to define is the URL. So we are going to ingest the data from a S3 bucket inside the folder line item underscore CSV. So go to that location, copy the S3 URI, and in place of URL, paste the URL that you have just copied. Now this stage refers to this location in the S3 bucket. So everything which is present inside the line item underscore CSV folder will be ingested into the table line item. And then finally, we are going to define the file format which we have just created, which is CSV underscore load underscore format. So once this is done, let's go ahead and run it. So the stage object has been created. Now it's time to list the contents present inside the stage object. So I'm going to write list at the rate, and then I'm going to write name of our stage object. So this command shows you a list of all the contents present inside the stage object, meaning everything which the stage refers to has been listed. You can see that it is displaying all the files which are present in our S3 location that it refers to. Now it is time to ingest the data, which is done by using a simple copy command. So the command says copy into, then we have to provide the table name, which is the line item. And after the from phrase, we have to provide the name of the stage object. After that, we have to define the file format, which is going to be the format that we have just created. And then we have to define what happens on error. So we are going to abort the statement in case of error. Let's run it. And you will see that all the files present inside our S3 bucket inside the table line item underscore CSV have been loaded, and you can clearly see the status to be loaded for both of the files. Moreover, you can also see the number of rows that are parsed. Now I am going to run a simple count command. So I'm going to write the command select count1 from line item. Upon running, you will see a total of 1473 rows inside the line item, which is equivalent to the sum of rows or present inside both of the files that were ingested from our S3 bucket. Let's go ahead and view some of the data. So I'm going to write a command select star from line item, and I'm going to limit the number of rows to 10. Upon running, you will see the first 10 rows from the line item table that have been ingested from the files present inside a S3 bucket. So this is how you can ingest CSV files from the S3 bucket to your Snowflake table. That's all for this video. I'll see you in the next one. Welcome back. In this video, you will learn how to ingest a JSON file from your S3 bucket to Snowflake table. Let's start by changing my role to sysadmin. Then I am going to use the schema e-commerce underscore dev. Let's run it, and your schema has been changed. Now we are going to create a file format just like we did in the previous video, but this time the file format is going to be for the JSON file. So I'm going to call it JSON underscore load underscore format. Then we have to define the type, which is going to be JSON. In case of JSON, creating a file format is really simple. You simply have to define the type of the file format. Let's run it, and your file format for JSON has been created. Next, we are going to create a stage object similar to what we did in the previous video. The name of the stage object is going to be stage underscore line item underscore JSON underscore dev, depicting that it is going to be a stage object for the table line item, and the type is going to be JSON. Next, we are going to define the storage integration, which is going to be our integration object that we created in the first video of this section. After that, we have to provide the URL just like we did for the CSV file. So go to your AWS S3 bucket. Inside the folder line item, go to the folder line item underscore JSON and copy the S3 URI. Then come back to your Snowflake and paste it in place of URL. And the file format is going to be the file format that we have just created. Let's go ahead and run it, and you will see that your stage object for JSON has been created. Once you create the stage, the next step is to list the contents of your stage. So I'm going to use the command list at the rate, and then I'm going to write the name of my stage object. Run it, and you will see the files that are present inside your S3 bucket and are now in your stage object. After that, I am going to use the copy command, and I'm going to write copy into the table line item Then I'm going to define the stage object, which is stage underscore line item underscore JSON underscore dev. And then I'm going to define on error. We are going to abort the statement. Once you run this, you will get an error. It says JSON file format can produce one and only one column of type variant object. Now, what does this mean? So, if you know that JSON is a semi-structured data and it has data in the form of key value pairs, as opposed to a CSV file where one row indicates the one row of your table and every column is split by a comma. So JSON is a bit different and it is quite similar to a Parquet file. So when it comes to JSON, you cannot copy the data as it is into a structured table. So what can we do now? Let's first query the stage table that we have now. So you can actually say select $1 from your stage object. So if you are selecting $1, it means that you are actually selecting the column 1 from your stage object. So here you can see the actual content of your file. So when it comes to ingesting JSON data or Parquet file into Snowflake, there are a couple of ways of doing so. We are going to see only one way in this video. The way that we are going to use is to create another table, ingest the data as it is into that raw table, and once you have the data in the raw table, you can actually transform the data and then load it into the structure table. Okay, so let's do that. So I'm gonna say create or replace table, line item underscore raw underscore JSON, and this table has only one column of type variant. Now, variant is a data type in Snowflake which can hold semi-structured or unstructured data. Okay, so now I'm gonna run this command and your raw table will be created. Let's refresh the schema and you will see that your raw table has been created. Now I'm gonna copy the contents of my stage into the raw table that we have just created. So instead of saying copy into line item, I'm going to say copy into line item underscore raw underscore JSON. Let's run it. Upon executing, you will see that both the files present in our S3 bucket have been successfully loaded into our raw tables. Now let's do a select star from this table to see the data. And I'm gonna limit the number of rows to 10. So you can see that the data has been populated inside the raw table. We can now copy the data, transform it into the way we want, put it in a structure, and then insert it into the line item table. And to do so, I'm gonna use this query here. So you can refer to the key or the value of the key by using a colon in Snowflake. So SRC is the name of my column. Since the table has only one column, right? So that's the name of my column. Colon the name of the key, and this is being done for all of the columns which were present inside the data file in the S3 bucket. Now let's run it to see the result. In the output, you can clearly see that we have actually structured our data the way we want. Now we can simply write another query, insert into line item, and after that, we'll write this query. So you can see that all the rows have been ingested. Now we are going to select all the data from the line item by using select star from line item. And now you can see that all the data has been structured and has been ingested into our line item table. So this is how you can ingest JSON data from your S3 bucket to your Snowflake table. That's all for this video. I'll see you in the next one. Welcome back. In this video, you will learn how to create roles in Snowflake and how to grant different access to them. By the end of this lesson, you would have learned how to create a role in Snowflake, how to grant it access to a database, a warehouse, a schema, and how to grant it select access to different views. And finally, we are also going to see how we can run the getDTL utility on our views. We will start by changing our role to account admin. Sysadmin is not being used because we are not manipulating the database. Then I will use the schema in which our tables are present. Now I will create a role by using the command create or replace role, and I am going to call it view role because it is going to have view access. After creating the role, the next step is to grant access to it. So I am going to start by giving it access to the warehouse, which is our compute SH, and I am going to give it the usage access. Okay, there is a typo. Oh, I have written grant instead of grant. Run it again, and now your access rights will be successfully allocated. Similarly, I will grant the role the usage access to the database as well. And similarly, I am also going to grant it the access to our schema, which is e-commerce underscore live. After granting the access to the warehouse database and schema, now I am going to grant it access to our views. I am going to only grant the select access to the role. And finally, I am going to grant this role to a particular user. Here I am going to use my own username. Now I will test the getDDL on the new row. The getDDL function returns a DDL statement that can be used to recreate the specified object. And for that, I am first going to switch my role to the newly created role. And here you can see that once the role is switched, the other databases and schemas are gone and only those are visible which the role has access to. Similarly, in the warehouses, only compute sh is visible. Let's check whether the database schemas and the views are actually accessible by the role or not. We have changed the schema and it is accessible. Now I am going to select the view. Upon running, you will see that view will be displayed, which means that the role has access to it. Now I am going to run the getDDL on this view. It will display us the data about object, which in this case is the view. Now it is to be remembered that this view is a simple type of view. Now I am going to run the getDDL on the secured view, where the first parameter is the view and the second parameter is the name of the view. Upon running, you will get an error that it cannot access. And this is the main advantage of using the secured view, as it does not expose the underlying data to any role. And this is all about roles in Snowflake. I'll see you guys in the next video. Welcome back. In this video, we are going to talk about the streams in Snowflake. So the stream is a way of implementing a change data capture. And what does change data capture mean? It's basically a process of capturing all of your DML operations that are happening in your table. These can be inserts, updates, or delete. And the streams capture CDC in the most efficient format in Snowflake. It is very efficient because it comes as a built-in function in Snowflake. So you can think of stream as a table that makes this change data available to you, indicating what has changed in the source table between two transactional points. So a typical flow of data in any data warehouse looks something like this. So you upload your data into your AWS S3 bucket, and from the S3 bucket, it moves into your raw tables, which are also known as a staging area. And then from the raw tables, the data moves to your production tables, which is basically a structured table. So when you need to transfer your data, once it reaches the raw table into the production table, that's when streams come into action. So you can define a stream on your raw table, which will let you know how many rows have been newly ingested. And then only those newly rows will be ingested from the raw tables into the production table using the stream. So let's say 20 new rows come into your raw table, which had updates. So you can actually your production table on the basis of the data that you have captured using your stream from the raw table. So this is a very typical use case of streams. There are some other use cases for streams as well. For instance, updating your search history or search indexes. Moreover, streams can also use for streaming analytics and anomaly detection, for auditing transaction logs, for any event-driven data program, and for ETL pipelines for incremental data loads from your raw table into the production table. That's all about streams. In the next video, we'll see how we can actually implement the streams in Snowflake. That's all for this video. I'll see you in the next one. Welcome back. In this video, you will learn how to create standard streams and how to ingest data from the stream into the production table. By the end of this video, you would have learned how to create a standard stream for a staging table, how to view the inserted data in the stream, how to ingest the data from the stream into the production table. Moreover, you will also learn how to update the data in the stream and how to ingest the updated data back to the production table. I will start by switching my role to sysadmin and using the database e-commerce underscore DB. Inside this database, I will create a new schema called streams underscore test, and then I will simply use this schema. Now, what I'm going to do is I'm going to create two tables, member underscore raw and members underscore prod. The members underscore raw is going to be our staging table where the data will be temporarily stored, and the other table is going to be our production table. Next, I'm simply going to create a stream for our raw table so that I can monitor and track all the data that is coming into the raw table and then accordingly ingest it into the production table. In the next query, I am going to use a system function stream get table timestamp. This function will give us an offset of the stream. Right now, it should be 0 because nothing is ingested and nothing is tracked. So far we are good. Now I will insert 5 rows into the members row table and each row will have an ID, a name and fee. Let's have a look at the streams, and upon running the query, you will see that all the 5 rows that we inserted are present in the stream. And in the stream, you can see that the metadata transaction says insert. This means that all the data has been inserted. Let's have a look at the timestamp offset, and you will see that once again it will be 0 because we have not consumed the data from the stream, we have only selected it. Consuming the data means transferring data from the raw table into the production table. Now I will insert rows into the production table, which will be from the rows that are present in the stream where the metadata transaction is inserted. Upon running, you will see that the data has been transferred to the production table, and once we run the stream, you will see that there are no rows inside the stream, that is, the stream is empty. Now, if we again look at the timestamp offset, we will see that it will give us the timestamp when the data was ingested from the stream into the production table. Then again, I'll add 3 rows into the raw table, and upon viewing the stream, you will see that those 3 rows will be present inside the stream. Now I will update a row in the raw table, and upon running, you will see that 1 row has been updated. Let's have a look at the stream, and here comes an interesting part. You will see that for the ID 7, the fee is updated to 10, but the metadata transaction shows insert and the metadata update is false. This is because we have not consumed the data from the stream before updating it. Now I will ingest the data from the stream into the production table, and upon running you will see 3 rows inserted. Let's have a look at the stream, and once again you will see that the stream is empty because we have ingested data from the stream into the production table. Once again I will update a record from the raw table, and upon executing you will see that 1 row is updated. Let's query the stream once again, and in the output you will see something very interesting. Here you can see that we have 2 records for ID 7, one with the metadata action insert and the other with the action delete. After updating the record, we will consume the data into the production table using merge, which is like an upsert in which we define a condition, and once the condition is matched, we define a statement which is executed once it is matched, and we also define a statement which is executed when it is not matched. Upon executing, you will see that 0 rows inserted and 1 row updated. And finally, I will view the production table, and in the output, we will see a total of 8 rows inserted. And this is all about standard streams. Thank you. Welcome back. In this video, we are going to take a look at what are the append-only streams. The working or the execution of the streams is simple and same as the standard stream, but they both differ conceptually. So if you have completely understood what we did in the last video, then creating and implementing an append-only stream will be easy for you. I'm going to start executing similar SQL statements. So let's start by creating the raw table. And after that, I'm going to recreate the members underscore prod table, which is going to be our production table. Now I'm going to create an append-only stream. And the syntax will look something like this. It's going to say create or replace stream. Give it a name like members underscore append underscore stream. Then we define on table, which is members underscore row. And after that, we are going to set the append-only flag to true to describe that it is going to be an append-only stream. And this is the only difference between the implementation of the standard stream and the append-only stream. Let's run this, and your append-only stream will be created. Now let's quickly check the screen. and it's empty as expected. Let's also check the offset, and it should also be 0, and yeah, it's 0 because nothing has happened yet. Now let's go ahead and insert 5 rows into your raw table. 5 rows have been ingested. Now let's run a select query to view the data from the stream. Let's run it and you will see all the 5 rows inside your stream. And this is because append only streams captures the newly ingested rows. Let's look at the offset again, and it's supposed to be 0. Now I am going to consume the data. For that, I'll execute an insert statement. Insert into members underscore prod. I'll pass the ID, name, and fee. And I'm going to select these members from the stream. You know that append only streams only captures the newly ingested or inserted data. Let me run this. So now 5 rows have been ingested. Now let's quickly have a look at the production table, and you will see 5 rows inserted into it. Now let's check the stream, and it is empty. As expected, because we have consumed the data from the stream into the production table. Let's have a look at the offset now, and now it is going to give us a different value of time. Now I want to show you guys that the append only stream does not work in case of updates and deletes. Right, so let's quickly update the raw table. So I'm going to update a record where the ID is 4, and I'm going to set the fee to 10. So the data has been updated. Now let's have a look at the stream, and you will see that it has not captured any data. This is because it can only capture the ingested or the inserted data. And same is the case for deletion, that if you delete a row from your raw table, then it will not be captured by the append only stream, and the stream will be empty. So that's how the append only streams work, and that's how they are different from the standard stream. That's all for this video. I'll see you in the next one. Welcome back. In this video, you will learn how to connect Python with Snowflake on your local system. Python is one of the go-to scripting languages that we might need for a day-to-day engineering task. And it becomes extremely simple when it comes to using Python with Snowflake, because all you need to do is to install a Python Snowflake connector. And this can be done using a simple pip command. Just go ahead and have a look at the Python connector API for Snowflake and see all the methods available for it, so you can easily understand what are the methods, what it can do, and what are the parameters required. So we are gonna get started with executing our first Python job by writing script from our local system which connects to our Snowflake account. So I'm gonna go back to my editor. You can use Visual Studio Code or any other IDE that you want. I'm using PyCharm. And the first thing that you need to do is to install the Snowflake connector for Python. And for that, I'm going to open the terminal and type the command pip install Snowflake connector Python. Here you don't need to specify any version, it will automatically install the latest available version. Execute it, it will take some time and install some other libraries as well, and after a while, your Python Snowflake connector will be installed and will be ready to use. So once this is done, I am gonna go ahead and write a few lines of Python script here on the PyCharm. Firstly, I'm going to import the Snowflake connector which I have just downloaded using import Snowflake connector. After that, I'm going to use the connect function of the Snowflake connector. Now this function accepts certain parameters. The first one is the username, which is going to be the username of your Snowflake account. The next value is the password for your Snowflake account. Then you have to provide the account value. And for the account value, firstly you need to pass your account ID, add a dot, and then you have to place the region of your Snowflake account. Next, you have to provide the name of your warehouse, the database name, the schema in which you have to access the data. Then you have to define the role. The role can be either sysadmin or the account admin. I'm going to use account admin. You can use sysadmin as well. And then we have to provide the session parameter, which is going to be the time zone. Once this is done, I am going to convert it into a cursor, and then I am going to create a SQL query in which I'll select star from the line item and limit the record to 10. Then I'll pass this query to the execute function using my newly created cursor, and it has functions like fetch all and fetch one, etc. And you can use these functions to get either a single row or all of the rows respectively, and you can simply print either the single row or all the row. And once this is done, finally you will close the cursor as your connection. And once all of this is written, I am going to go ahead and run the code. Okay, I got an error. It says could not connect to the Snowflake backend after one attempt. Okay, I think I provided the wrong values for the account. Go back to your Snowflake account, and in the bottom left corner, you can see your Snowflake logo and an ID. Click on it and you will see all the available accounts. The first one having a tick is the current account. Click on it and you will see some information about that Snowflake account, which is going to be the account ID, and then you will see the organization. So you simply have to copy the account URL, go back to your PyCharm or the ID in which you are working, and in the account place, paste the URL that you just copied. And from here, you have to remove the AWS.Snowflake computing. Once this is done, run it again, and yeah, you will get all the data present inside the line item. So you can see that we have connected our Snowflake account with Python on our local machine by using the Python Snowflake connector. That's all for this video. I'll see you in the next one. Welcome back. In this video, you will learn how to deploy and execute a Python script on AWS Glue. In this video, again, I am going to use the same script which I have been using in the previous videos. And you already know that the script has an external dependency, which is the installation of Snowflake Python library, which doesn't come built in Python. So we have to specify the paths to this library. And how do you do it? You can do it by creating a WHL file. You guys don't have to create the file. I've already created it and it will be present in the resources of the lecture. In order to add the WHL file, you need to go to your S3 bucket. I've already created one. And inside your bucket, you have to create a folder called WHL. I've already created it too. Then go into the WHL folder and upload the Snowflake connector WHL file here. I would suggest you to use the same WHL file for this course in order to go through the course smoothly. So once you do that, let's go back to our PyCharm or the ID you are using. This is the same script that we used in the previous videos. And I've added a new line here which is from AWS glue.utils import get result options. We are not going to use this in this particular lecture, but it will be used in the later on videos. Everything else will be the same, and I'm going to go back to my AWS account, and from there I am going to search AWS Glue. Once you land on the page, from the left navigation menu, you have to click on ETL jobs. And after that, you will land on the AWS Glue Studio. From that, you will have the first section saying create job, and it will provide you multiple options. You have to select the Python shell script editor. Once you select it, it is going to ask you to either create a new script with boilerplate code or upload and edit an existing script. Since we have already written a script on our local system, so I'm going to select upload and edit an existing script. Then you'll go ahead and simply choose the file that you want to upload having the script. So this is the script that I am uploading in my AWS Glue. Once the file is uploaded, simply click create. After that, you will be redirected to a new page where your script will be automatically loaded and it will be totally editable. Our script is fine, so let's go ahead and click save button. Okay, it is asking me to rename it. So I'm going to call it SF-connector. SF means Snowflake. Once this is done, now I'll click on the job details tab. And from here, it is asking me to select an IAM role. So I already have an IAM role, which is AWS Glue Service role. So I'm going to select that IAM role. The Python version will be automatically selected for you. Scroll down a little bit and then we are going to change the value for the job timeout interval. 2880 is a very large value, so I'm going to change it to 20 minutes. Then click on advanced options. It will ask you to provide a script file name. I'm going to call it sf-connector. Scroll down a little bit. I'm not going to add any new connections here, and once you scroll down more, you will see the library. So the first option is Python library path. Here you have to provide the path for the Python Snowflake connector library, which in fact is the path which is stored in the WHL files. So here we have to provide the path of the WHL file that we have uploaded. And to do so, go back to your S3 bucket inside the WHL folder, click on the WHL file that we have just uploaded, and then copy the S3 URI. Once the URI is copied, go back to your job details, and for the Python library path, paste the WHL file path. And that's it. No need to change anything else. Simply click save. Then we'll go to the script tab, and finally I am going to click the run button. After doing so, our job will start executing. It will going to take some time, and after a while you will see that our job has been successfully executed. And in order to see the data that is displayed from the line item table, scroll down a little bit, click on output logs, and you will be redirected to the logs page. Upon landing there, you will find a log link. Click on it. You will get a list of logs. Click the last row and you will see all the data which is fetched from the line item table using the script. So this is how you can deploy and execute a Python script on AWS Glue. That's all for this video. I'll see you in the next one. Welcome back. In this video, you will learn how to parameterize your Python script on AWS Glue. I'm gonna go ahead and make a few changes in my main.py file which I used in the previous video. Firstly, I am going to import the getResolved options, which is a built-in function in the AWS Glue.utils library. Then I'm going to use this function and pass two type of parameters. First is going to be the argument and the other one is going to be the argument list. So for the argument list, I am going to pass the supplier key and the ship date. Then I am going to grab the value of these parameters from the args and store it in a variable called supplier key and the ship date. Then I am also going to change my SQL query and I am going to use these arguments in my SQL query. I'm gonna write select star from line item where L underscore ship date is the 0th value or the first value of the args array and L underscore supply key is the second value, which means the value at index 1 of the args array. Then I am going to pass this query to the execute function and then I am going to get its result using the results.form.ssqid function. Let's copy all of this and I'm going to go to my AWS Glue. I'm going to edit the script, paste all the text there and save it. And then I'm simply going to run the script. Upon running, you will get an error and your job will fail. This is because we have passed the parameters via the script, but we have not actually passed the parameter values while running the job. So in order to add the parameters, I am going to go towards the job properties and inside the job properties, I'll scroll down to advanced properties and then I'll see the job parameters. Since I'm going to use two parameters, so I'm going to add two values here. First one is going to be the supplier key and the other one is going to be the ship date. And you can see that for these keys, the value is optional, so I'm going to leave it empty. And once it is done, I am going to save the script and then on the runs page, I am going to click the actions button and from there I'll select run with parameters. The job will take some time to execute and in the meantime I'll pause the video and I'll come back to see the result of the execution. Okay, so the job execution has succeeded, which means that our job is successfully executed. Now in order to see the output, scroll down a little bit and you will see the output logs. Click on it and you will be redirected to a new page. From there, scroll down, you will get the log link. Click on it and the last value will show you the output data. You can click it and see all the data which was present in the line item has been displayed to you. So this is how you can parameterize your Python script using the AWS Glue. That's all for this video. I'll see you in the next one. Welcome back. In this video, you will learn how to use the pandas library on a script in your local system and then run this script on AWS using AWS Glue. Let's go to our PyCharm and from there, firstly, I'm going to install the pandas library by writing the command pip install pandas. The installation is going to take some time and after a while, it will be installed and ready to use. So once this is done, I'm gonna go ahead and make a few changes to the file that we used in the previous video. Firstly, I'm going to import pandas library using the command import pandas as PD. No need to change the Snowflake connected.connect function, but after that, I'm gonna change the SQL query. Here I'm going to write select star from line item limit 10 and then instead of using the execute function, now I am going to use a pandas library read underscore SQL function in which I am going to pass the SQL query and the connection. And then I am going to print the data aggregated by using the head function. And then finally, I am going to close the connection. Once all of this is done, go ahead and execute your script. I am going to run it using the terminal by writing the command Python and then give the name of my file, which is main.py file. It has given me an error. Oh, I forgot to remove the get resolved options line. So I'm gonna go ahead and comment this line. And I'm also going to comment out the arguments line along with the supplier key and the ship date. Once all of this is done, go back to your terminal and run your script again. Upon executing, you will see the 10 rows from the line item table along with its header. Now I am going to copy all of the code from this script, go back to my Snowflake, and then I am going to edit my script. I am going to paste all of this code on the script there, save it, and then I am simply going to run the job. The job will take some time to execute, and after a while, you will see that your job has been successfully executed. Now, if you want to see the output, scroll down a little bit and you will see the output logs. Click on it and you will be redirected to the logs page. Upon landing on the logs page, scroll down a little bit and you will see the log link. Upon clicking, scroll down and the last row will be all the data which we fetched from the line item table. Click it and you can see that it is similar to the data that we got while running the script on our IDE. So this is how you can use the Python's pandas library with Snowflake on AWS Glue. That's all for this video. I'll see you in the next one. Welcome back. In this video, we will have a look at how you can set up Kafka on your local machine. By the end of this video, you would have learned how to set up Kafka on your local machine, how to start the Zookeeper server, how to start the Kafka server, how to create a topic, and how to produce and consume data from the topic using Kafka. In order to set up Kafka locally, you will have to first start the Zookeeper. And for that, open cmd in your Kafka directory and write the following command to start the Zookeeper server.bat file. Once you click enter, your Zookeeper will be started. Now the next step is to start the Kafka server. For that, open a new cmd and type the following command in it. And once you enter it, the Kafka server will be created and you can verify it by looking at a port 9092 in the output. Now the next step is to create a topic. For that, open another cmd and type the following command in which you have to define the Kafka topic name for which you want to create the topic. You have to define the local host and the port of the local host and the bootstrap server. Once you press enter, your topic will be created. Now we will write the data into the topic, and for that we will use console producer. I am going to copy the above statement and make certain changes to add console producer in it and remove the create flag. And once I insert it, it is going to prompt me to enter the data that I want to insert into the topic. Type in all the data that you want to insert into your topic, and the data can be in the form of multiple lines. Once you are done with typing the data and you want to move out of it, simply press Ctrl and C. You will be prompted to enter Y or N. Press Y and you will move to the console. And then finally, we will read the contents of the topic. For that, I am going to again copy the above statement, and now instead of console producer, I am going to use console consumer object, and here I will insert a flag of from beginning to read the data from the beginning. All the data in the topic will be displayed. And this is all about setting up Snowflake with Kafka on local system. Thank you. Welcome back. In this video, you will learn how to configure the connection between Kafka running on the local system and the Snowflake. By the end of this video, you would have learned how to configure the Kafka Snowflake connector by using the sf_connected.properties file and the connect standalone.properties file. Let's start the configuration. I want you guys to go into your Kafka folder, go into the config folder, and then create a new text file and give it the name sf_connect, and extension should be properties. Once the file is created, open it in an editor and write the following code in it. In the configuration file, we have to fill out the empty parameters. So the first parameter is topics. Here I'm going to define a topic name. I'll give it sales-data. Don't worry, we'll create this topic later. Then we have to provide a topic to table mapping. So the first parameter is going to be a topic name, which is sales data, and after a colon, we are going to define the table name, which will be created in Snowflake to map the data. Then for the buffer count, enter 10,000. You can give any value to your buffer flush time and buffer size words. I am going to give 60 and 500,000. Now for the Snowflake URL name, go to your Snowflake, copy the first parameter from the URL and paste it in the link here. It is going to be the username, then copy the region and paste it after a dot, and your URL should look like this. Now for the Snowflake username, you have to provide the username of your account. I am going to give it mine, and let's leave the private key for now on. Give the database name. We are going to use our database that we are previously working on, which is e-commerce DB. And for the schema name, we are going to use Kafka_live_streaming. Don't worry, we are going to create it later on. And here you have to provide a name, and for that you can give Kafka_live_streaming_data. Save your sf_connect file, and now within the same config library, open connect standalone.properties file. Here we only have to change one thing, which is the plugin path, which is the last line of the file. Here we have to provide the lib folder path of our Kafka. Go to the libs folder inside Kafka, copy its path and then paste it inside your configuration file. Save it and you will be good to go. Now in the next video, we will see how to set up the private and public key in the sf_connect file. Welcome back. In this video, you will learn how to set up encryption keys for Kafka with Snowflake. By the end of this video, you would have learned how to create and set a 2048-bit RSA private key, how to create a 2048-bit RSA public key, and how to assign RSA public key to a particular user in Snowflake. For the private key, go to your browser and open the link. This one, it is going to give you an option for the key size. From the option, select 2048-bit, and then here you can generate the private key and the public key. So the private key that I have created, I'll copy this, and in the private key here I am going to paste all of this. Okay, remember to make the private key of 2048 bits. Now after pasting the key, you have to add a backslash after each of the row until the second last row. Okay, then simply save it. Now we will set up the public key. If you remember that when we generated the private key using link, the public key was automatically generated. So let's copy this public key, and here inside your Snowflake worksheet, I have executed two rows in which I have changed the role to sysadmin and I have used the schema e-commerce_live. Now I am going to alter the user. Here we will set the RSA public key to the public key we just generated. Okay, let's execute it. And you can see that RSA key is set. Now I am going to describe this user to see whether the RSA public key has actually been set for this user or not. Here you can see different parameters for the user, and in the RSA public key, you can see that this public key has been set. Okay. So this is how you can set the public and private keys for your Snowflake account for a particular user. That is all for this video. Thank you. Welcome back. In this video, you will learn how to create a topic, how to insert data in a topic, and how to stream the data from the topic into a Snowflake table using Kafka. If you remember that when creating the fs_connect file, we set the Snowflake schema name to Kafka live streaming. Let's create it now. Go to your Snowflake account and inside your worksheet type create schema and give the name Kafka_live_streaming and run it. Refresh your database and you will see that the schema is created. Now we will actually convert our Kafka server with our Snowflake account and make sure that your Zookeeper server and the Kafka server are running on local machine. But before that, let's use the created schema. Inside your Kafka folder, open a new command prompt. And once the command prompt is open, write the command to create a new topic, and in place of sales-data, enter sales data. You also need to change this topic name in your sf_connect file for the topics data and for topic to table mapping. Press enter and your sales data topic will be created. In order to write the data into the topic, use the console producer command and mention your topic name, and once you press enter you will be prompted to enter the data. I am going to insert the data in the form of JSON having 3 attributes: name, age and car. Once you are done with writing the data, press Ctrl and C. You will be prompted to enter Y or N. Press Y and you will move out of the console, right? Once the topic is created and the data is loaded, open a new command prompt to connect the Kafka with the Snowflake in order to start streaming. In the new command prompt, enter the command to open a new file which is connect-standalone.bat file, and along with this file open two other files which is the connect-standalone.properties file and the sf-connect file that we previously created that contains the configurations. The files connect-standalone.properties and sf-connect.properties are very important because they contain the configurations for connecting the Kafka with the Snowflake. Upon executing, it will take some time for streaming the data, and after a while, your streaming will be done. Now, let's verify this streaming in Snowflake. Go to your Snowflake account and refresh the databases. Then navigate to the table and you will see that the sales data table is created, but right now it does not have any rows in it. Streaming data from Kafka to Snowflake will take some time. Refresh it again and then you will see that one row has been inserted into your sales data table. Let's view this data. Move to your worksheet and type the command select all from sales data. Upon running, you will see that the data that we inserted into our topic has been successfully streamed from Kafka into the Snowflake table. And this is how you can pass data from your Kafka running on your local system to your Snowflake account. Thank you. Welcome back. In this video, you will learn what is cloning in Snowflake. Snowflake says that cloning is a quick and effortless process. Yes, technically it is, however, there are a lot of ifs and buts, and it is always not that easy as it seems. As you know that we can clone tables, schemas, and databases. Let's say you want to clone a database, and the database may have one or more schemas, and each schema may have many more objects like tables, file formats, sequences, stages, streams, tasks, and so on. Moreover, there will be roles and grants too associated with this object. And you can think of many questions like, is it possible to exclude some of the objects while cloning is done at database or schema level? What happens to the file ingestion metadata with pipe and other copy commands? What happens with unconsumed stream data? Another question that arises is that can the transient and temporary tables be also cloned? And what happens to unnamed stages? And many more never spoken rules, including the time travel feature applicability. I will answer these questions in the next video. So, cloning, also referred to in a zero copy clone, creates a copy of your database, schema, or a table without having any physical copy from the source object. And that's why it is called a zero copy clone. It is basically a point in time snapshot of data which is present in the source object. It could be database, schema, or a table. Any of this value is taken when the clone is created and is made available to the cloned object. The SQL syntax for cloning is very simple, and simply by using the clone keyword, you can create a cloned object. Since it does not copy any physical data, the clone works instantaneously no matter how big the database schema or a table is. We will try creating a table using a clone versus create table as a select statement and see it's working live during the hands-on session. That's all for this video. I'll see you in the next one. Welcome back. In this video, you will see a comparison between a clone and a snapshot. Let's understand clone versus snapshot. using a visual representation and underlying physical micropartitions concept which we have covered in the previous section. Let's assume that we have a time horizon and we have a customer table, and we can easily call it a source table. At a time t1, we clone the customer table and make a clone table. The clone table is a point-in-time snapshot, and under the hood, it refers to the same micropartition physical files of the source table. So right after the clone operation, both the objects are exactly same. And when the query is executed on the clone table or even at the source table, at a time t1, they refer to the same micropartition. Let's further assume that the source table is from the production environment and the clone is made to the non-production environment simply for debugging purpose. As we move further in our timeline dimension, the prod ETL made some changes to the customer source table, and at the same time the development team has added, deleted and updated some of the records in the clone table. Now, these actions will create separate physical files post-clone, and these operations are completely independent. After the changes are made to the cloned object as well as in the source object, now both these tables are completely unequal. So you can say that the cloned object is a writable and is independent of the source object completely, and changes made to either the source object or at the cloned object are not part of each other. That's all for this video. I'll see you in the next one. Welcome back. In this video, you will learn the effect of cloning on different objects and which objects can be cloned automatically. Let's understand which all objects can be cloned and gets cloned automatically when the database or schema objects are cloned. So when you clone a database using a clone keyword, a point-in-time snapshot is created without making any physical copy of the actual underlying data for that database. All the schemas under the database is also cloned. All the objects listed above, permanent table, file format, sequence object, named external stages, pipe, streams, and tasks are also copied along with the schema. When it comes to the database cloning, the roles and grants, they are also cloned for a child object, means for a schema or a table level. However, the database level grants and roles are not copied. So in this case, the schema and all other objects under the schema grants will be cloned, but the database grants will not be cloned. And this is the most important point to remember when working with zero-copy cloning. Let's summarize it a bit. So these are the 8 objects which can be cloned as per the Snowflake documentation. However, if you clone a database or schema, there are many other objects which belongs to the parents will get cloned automatically. So there is a difference between what can be cloned and what gets cloned automatically from the parent object. Users and user roles cannot be cloned using the clone keyword. And there are also many other account level objects which are not candidate for cloning. We'll also see some interesting behavior of the transient and temporary tables during the hands-on exercise. But that's all for this video. I'll see you in the next one. Welcome back. In this video, you will learn how to perform table cloning in Snowflake. So let's go to your Snowflake trial account and let's start playing with the clone feature. I'm going to create a simple order table and then I'm simply going to execute the query. And you can see that our table has been successfully created. Now let's populate few thousand rows in this table using a select statement. You already know all these things, so I'm not going to repeat them again. Let's execute the query. After execution, you will see that 100,000 rows have been inserted into a simple order table. Now let's quickly validate the insertion. For that, I'm going to select top 10 rows from the table. Upon execution, you will see that data has been successfully ingested into our table. So this is the order table with the order key, customer key, order status, total price, order date, and order priority. Before we clone the table, let's perform one delete operation. So we can also validate the time travel feature alongside. So I am going to delete the order key between 30 to 40. And let's see how many records get deleted. Upon execution, you will see that a total of 8 rows have been deleted. Now we will create a new table called the simple order clone using the clone keyword. So the SQL syntax is pretty straightforward. Here you can see that we are using a clone keyword, and here I am creating a clone using a simple order permanent table. Upon running, you will see that our clone table has been successfully created. Now let's take a table count from both the tables. For the simple table, the count is 99,992 rows because we have deleted 8 rows. Now the clone table should also give the same number of rows. And yes, it is again 99,992 rows. Now I would like to ask you a question. Is it really a zero copy clone? To identify that, we need to check the information schema table dataset. Let me run the information schema table for you. So I'm going to run the query to select the information schema from the tables, a simple order and the simple order clone which is present inside the table schema e_dev. Once you run it, you will get two tables. Here you can see that I have a simple order table which is the primary table, or we can also say that it is a source table, and then we have a simple order clone table which is a clone table, and I can see that the row count for both the tables is the same, and the byte size and the retention time is also the same for both the tables. So in short, everything looks exactly the same for both the tables because it is a point in time snapshot. One thing to remember is that the table name must appear in the uppercase because in Snowflake everything is stored in uppercase. Now let's check the byte fields in the table storage matrix view. And to access this, we have to use the account admin role. So firstly, let's just switch the role to the account admin. Now let me run the query on the table storage matrix and filter the table name simple order and simple order clone on my schema which is e_dev. Upon running, you can clearly see that I have a clone table and I have a source table through which the table has been cloned. Now for the clone table, my active bytes are still 0. And for the source table, which is the simple order table, here we have a large number of active bytes. Since we have performed some delete operation, so I have data available for my time travel bytes. So this proves that when you make a clone of a table, at that point of time there is no physical data movement or copy has happened under the hood, and it is just referring to the physical partition file of the source table. However, as I've already told you that as we start making changes, the simple order clone will start getting some active bytes. Now let's make some changes independently and validate the behavior. Okay, so now I'm going to insert 1000 rows into the simple order table. Upon running, 1000 rows have been inserted. And don't worry about the duplicate rows, this is just for validating the clone feature. Now on the clone table, I am performing some update operation. So you can see that roughly 60,000 rows have been updated. Now let's check again how the information schema looks like. You can see that for the orders table, I got a different row count, but in the clone table, I still have 99,992 records. So the bytes are also changing for both the simple order and the simple order clone table. So if I go and validate my total storage matrix, this will show me a different number, and now the clone table will not have the 0 values. Now you can see that the active bytes have changed from 0 to a new number. Right after the clone operation, both the tables are referring to the same partition. However, after that, the clone object is a writable object, and any changes done on the cloned object will have its own partition files and its own storage. So that's all about cloning the simple tables. That's all for this video. I'll see you in the next one. Welcome back. In this video, you will learn how to perform a table copy clone on the transient and temporary tables. So I'm going to start by creating a transient table, which is going to be for the order data. Let's execute the query, and upon running, your transient table will be successfully created with the name trans_order. Now I am going to populate this table with 100 rows. And upon running, you will see that 100 rows have been successfully inserted. Let's validate the insertion. For that, I am going to write the query select star from trans order. I am going to limit the number of records to 10. And you can see that the table has been successfully populated. Now let's clone the table using the trans_order table. And here I am going to create a permanent table from the transient table. Is it allowed in Snowflake? Let's see. Okay, it says transient object cannot be cloned to a permanent table. It means that when I clone a transient table, I can only create a transient clone table. Let me execute another SQL statement. Here I am going to create a transient table and I am going to clone it from another transient table which is trans_order. Let's execute the query and you will see that our query has been successfully executed, which means that a cloned transient table has been created. Now I am going to write another query to view the trans tables, and I can see that I have a trans order table and a trans order clone table. Both tables have the same number of rows and same number of bytes. Now let's see how a temporary table works. So I am going to create a temporary table called temp order. Okay, my temporary table got created. Let me populate this table with 100 rows. And you can see that 100 rows have been successfully inserted. Now let's quickly validate the insertion and you can see that data has been inserted correctly. Now I am going to clone this table. So I am going to create a temporary table called temp_order_clone from the temp order table. Upon execution, you will see that our clone table has been successfully created. And it is the same case like the transient table that you cannot create a permanent table clone of a temporary table. Now let's check if we can create a transient table from a temporary table. So I'm going to execute the query and you will see that yes, it is allowing us to create a transient table from a temporary table. So I have got two clone tables created from my temporary table. One is the transient clone table and the other one is the temporary clone table. However, permanent table is not allowed. Now I am going to view the tables that starts with the keyword temp. And you will see that I have a temp order table, a temp order clone table, and a temp order clone 1 table. And you can see that the number of rows and the number of bytes are exactly the same in all the 3 tables. Another question that arises is that, can I create a transient or a temporary table from a permanent table using the clone feature? Let me try that. So I am going to create a table called permanent to trans, which is a transient table using the clone feature. And second, I am going to create a permanent to temp table, which is going to be a clone of the permanent table simple order. Now let's execute these queries one by one. So my first query has been successfully executed, which means that we can simply create a transient table from a permanent table. Now let's execute the second query. The second query also executed successfully, which means that we can create a temporary table from a permanent table as well. So in simple words, we can say that a permanent table can be cloned to a permanent, transient, and temporary table. However, the transient and the temporary tables cannot be cloned to a permanent table. That's all about transient and temporary tables and how you can clone these tables. That's all for this video. I'll see you in the next one. Welcome back. In this video, you will learn how the object dependency works with the cloning feature. Here, firstly, I am going to create a sequence object which is going to be even_sequence. It is going to start with the value 2 and increment every time by 2. Next, I am going to create a table which is referring to a sequence object. And this sequence is used to generate a next value. Next, I am going to create a new table called the order with sequence table having a sequence as an identity object. Here, we are actually creating an object dependency. And this dependency is within the same schema. Let's execute it and you can see that our table with the dependency has been created. Now I am going to populate this table with 100 rows. Upon executing the query, you will see that 100 rows have been successfully inserted. Now let's quickly validate the dataset and the sequence IDs. And for that, I am going to write the query select star from the order with sequence table and limit 10. In the output, you can see that I am having a sequence ID starting with 2 and it is having an increment of 2 for each value. Now I am going to create a clone table which is called order sequence clone using order with sequence table. Okay, so our table has been successfully created. And you should remember that the table that we have just created is a clone of the table having a reference to the sequence object. Now, how do I know whether it has copied the reference correctly or not? For that, I am going to use the getDDL function. Here I can see that it has copied the sequence object reference properly. However, if your sequence object belongs to a different schema or a different database, make sure that you validate that this table has a usage access to that particular sequence, and that has to be created manually because the clone doesn't do it if I am cloning the table directly. However, if you are trying to do it at the schema level or a database level cloning, then this will happen automatically as long as the sequence object belongs to the same schema or the same database. In that case, your grant and role will work properly. Now let's try to insert some extra record into the cloned object and see if the sequence is working properly or not. So here I am inserting 50 rows using the insert statement. Okay, so 50 rows have been inserted. So since it is incrementing the sequence value by 2, adding 50 more rows will make the incremental max value as a 300. Let's verify it by writing a select query, execute it, scroll down a little bit and you can see that the maximum value is 300. Let's run another select query on the source table, execute it and you can see that the source table is still having a value up to 200. So this means that after the cloning, both the objects become independent and internally they might be referring to some part of the partition from the same partition file. And that's the main feature of the zero copy clone, that once a cloning object is created, both the source and the clone table are independent of each other and they somehow refer to the main partition file. And that's all for this video. I'll see you in the next one. Welcome back. In this video, you will learn how to use the clone feature with the file formats and sequences. So I'm going to start by saying how many file formats do we have. So right now I have no file format. So let me create a new file format. The name of my file format is going to be CSV_FF. Type is CSV. Compression is auto. The field delimiter is a comma since it is a CSV file. Skip header is 0 because my file does not have any header. And then there are a few other parameters. Now let's execute it and you will see that our file format has been successfully created. Now, if I view all the file formats, you will see that we'll have a newly created file format, which is CSV_FF. Now, I am going to create a cloned file format using the CSV_FF file format. And you will see that our clone has been successfully created. Now, if I view the file formats again, I'll see that now instead of one, I have two file formats. One is CSV_FF and the other one is the CSV_FF_clone. The file format does not really hold any data. It is very easy to have a clone for a file format. Now let's see how many sequences do we have. And for that I am going to write the query show sequences. And you can see that right now I have only one sequence called even_sequence. Now let's create a sequence object using a clone function. And our sequence clone has been created. So let's view all the sequences again. And you can see that now I have two sequence objects. One is the source sequence object, which is the even sequence, and other one is its clone. Now, if I write another query in which I am going to select the next value for the even sequence clone and the even sequence, it gives me the exact same value for the next interval for both the tables. Now, I am going to alter the clone sequence object and change the increment from 2 to 3. Now let's see all the sequences. You can see that the interval time for the even sequence clone has been changed from 2 to 3. And the next value for both of them is right now 304. So if we select the next value for both of them again, one of them will have the value of 304 and the other one will have a value of 305. Okay, I executed it more than once. So now the next value for the even sequence clone is 307. And for the even sequence is 306. So this means that there is a change in the incremental value between the two sequences. I was expecting, since I have executed the alter statement, the very next statement should change. What does this mean? It means that the sequence object already holds the next value. So it is a very important observation here. And this is how you can use the clone function with the file formats and sequences. That's all for this video. I'll see you in the next one. Welcome back. In this video, you will learn how to clone the stream objects in Snowflake. So I'm going to start by creating an order table. Execute it and your order table has been created. Now I am going to populate this table with 100 rows. Upon execution, you will see that it has been inserted. Now I am going to create a stream object. This stream object captures all the insert, update and delete operations as a CDC. So this is the syntax in which I am going to create the stream, which is going to be stream order table on the table order table. So my stream is created. Let's view all the streams to verify the creation, and yes, our stream has been created. The stream tables are nothing but a kind of delta table, and any operation performed on your order table will be captured by this stream, and all those add, delete and update operations will be captured by your delta table, or in other words, the stream. Now again, I am inserting another 10 rows into my order table, and these 10 rows will be captured into the stream object. Okay, so we got the 10 rows inserted. Now let's see our order table. It should have a total of 110 rows. Yes, it has 110 rows. Now the stream order table is a delta table, and it will have only 10 rows, which are the rows that we inserted after creating the stream. So it is going to capture those 10 rows inside it. Yeah, so you can see that it has only 10 rows that we have just inserted. Now I am going to create another stream using the clone keyword, and I am going to use the stream order table. Okay, so our clone has been successfully created. So the stream object is basically a clone of the original stream. And let me see whether it is having the data available or not. Yes, it has all the data available in it. However, if your delta data becomes stale, and on that state, if you create a stream object using a clone keyword, then that stale object may not be accessible to your newly created stream object, which is created via the clone keyword. So this is how the clone and stream objects behave together. That's all for this video. I'll see you in the next one. Welcome back. In this video, you will learn how you can create a dashboard using Snowsight. The dashboard is one of the most important and powerful features in Snowsight, and sometimes people compare the dashboard with Power BI or a Tableau. In dashboard, we can add a dashboard, we can manage the filter, what we have seen in the worksheet. We can also view the dashboard with recent shared with me and my dashboard, very similar to the worksheet. I can delete and duplicate a dashboard, I can share a dashboard. Let's jump into Snowsight page and let's see how you can create a dashboard. For that, go to your Snowflake account and click on the dashboard from the left navigation menu. Right now, we do not have any dashboard, so this screen will come blank. Let me click on this Add Dashboard button, give a new name to my dashboard. Okay, so the dashboard has been created, and I can really choose the role in which I want to work. In addition to the role, I can also select the warehouse into which I want to create my dashboard. And once I select the warehouse, from here after, all the dashboard will bring the data from your worksheet which is present inside a particular warehouse. Now you have different type of tiles inside the dashboard. So tiles are nothing but a simple worksheet in which you can run your queries. So in order to create a dashboard, we need to have certain queries. So I am going to go to this predefined database, and inside this I am going to write a simple query that says select star from the Snowflake sample data tpch_sf1 orders table. And once you execute the query, you will see that it is going to fetch all the data from the orders table which is present inside the Snowflake sample data database. Now, in order to convert this data into some meaningful data, I am going to group the data on the basis of order priority. So the query is going to look something like this. So the query is select order status, count all from Snowflake, and I'm going to group it by order status. And once you execute it, now you are going to see data in a different manner. You will have different order statuses and the count of each order status. Now I want to convert this result into a chart. And for that, you simply have to click the chart button appearing on the top of your output. And you can also change the format of this chart by selecting options from the right menu to change chart in any way you want. So once my changes are done, I can simply go back to my dashboard. And now my dashboard is up and running, and it is displaying the first tile having the graph of the query that we executed just now. And if you want to add new tiles, then you can simply click the add button and a new tile, which is a new worksheet, will be created, and you can run different type of queries there and generate different type of graphs from it. So let's create a new tile and let me try something else. So I'm going to select all the data from the line item table. Let's run it and see what data does it have. Okay, so from all these columns, I can select the line status and group by the data on the basis of the line status column. So the new query will look something like this. I am going to select line status and then count all the data and group it on the basis of line status. Then I am also going to order it by 2 in the descending order. Let me run the query. You can see that it has given me different line statuses and the count of each line status present inside the dataset. Now I can also convert it into a chart, and from the right menu you can select the chart type. You can select line chart, bar chart, pie chart, or any other chart that you want. I'm going to select heat grid from here. Okay, this looks good now. Now I'm going to go back to my dashboard, and now you can see that instead of a single tile, now it is displaying me 2 different tiles, and the data executed on that tile is displayed in the form of a graph. Another thing that you can do is click on the share button and share this dashboard with any of the user that you want. But one thing to remember is that the user must be within the same organization. And this is how you can create a simple dashboard in Snowflake using the Snowsight. That's all for this video. I'll see you in the next one. Welcome back. In this video, you are going to learn about dashboard filters in Snowflake. The first thing that you should remember is that in order to apply filter, you need to have a worksheet. So to add a worksheet, we are going to add a new tile, and inside this worksheet, I am going to once again select the sample data database, and from that I am going to select the orders table. I am going to write the query, select O underscore clerk, and then I am going to calculate the sum of total price of all the orders, where order date is equal to, and then after equal to I am going to apply a colon, and once I click on enter, I am going to be provided with by order date filter, and once I click on the order date filter, you will see that on the top left corner a new tab will appear with the date filter, and from that range of dates you can select any date for the filter that you want. After that, I am going to group my data on the basis of O underscore clerk, and I am going to order it by 2 in the descending order. So once I execute it, I got the data with this sample group by statement, where I am actually calculating the total price for each clerk. Now let me choose a chart. So I selected a scattered chart, and I am going to add this to my dashboard. So just by going back to my dashboard, it adds this chart automatically to the dashboard. And on the top left corner, you can still see the filter. And if you select a different value from this date filter and click on apply, the chart will change automatically according to the new filter date, and the data will now correspond to the date that we selected from the filter. So this is how you can apply filters to your query in Snowflake and display it on the dashboard. So that's all for this video. I'll see you in the next one. Welcome back. In this video, you will learn how to create a dashboard using filters for COVID-19 dataset. Okay, so I'm going to start by adding a new dataset, and I'm going to use the dataset which is already present inside the Snowflake. And for that, you have to go to Marketplace. Once you land on the page, go to your search bar and you have to type COVID-19. And in the search results, you have to select the one which is from the star schema. So this is the one. I'm going to click it. And this is the data about the COVID-19, having data on the incidence and the mortality of COVID-19 cases as reported by the public health authorities worldwide. It also includes information on the public health measures as well as global vaccination data. So in order to get this dataset, you simply have to click on this get button, and once you click on the get button, this dataset will be added to your database. And in order to verify this, click on this data, and here you can see that from the list of databases, the COVID-19 dataset is also present. Now let's go back to our dashboard, and I am going to click on the new dashboard button here. I am going to call it COVID-19, since it is going to be a dashboard for the COVID-19 data. Then I am simply going to click create dashboard. Once on this page, I am going to add a new tile for the SQL worksheet. Then once you land on the worksheet, you have to change your database. Right now, the default database is e-commerce. Click on it and then select the COVID-19 database that we are going to use in this video. Okay, so you can see that now the database has been changed. And if you expand this database, you can see all the tables and the schemas which are present. So you can see a large number of tables are present there related to the test details and the mortality rate and the number of cases, etc. Now I am going to write a query to get the daily report that includes the total COVID-19 cases per country. So now I am going to start writing the query. I'll say select star from public dot World Health Organization daily report. And this is going to give us the daily report of the cases for each country. So let's run the query. And you can see that it has provided me data for different countries. For example, for America, the total cases for a day were 31,250 and overall cases were this. And same is the case for all the countries. You can scroll down and view any country that you want. So if you see the data set again, this one has the highest number of cases, which represents the global cases. So now I am going to change my query a little bit and I am going to extract the total number of cases globally. So I am going to filter this on the basis of country region. So I'll say where country region is equal to, says the country region in this scenario is null. So we are gonna leave this. Then I am going to say, instead of select star, I am going to select the country region and the total cases, which is here the cases total. Okay. Now I am going to execute the query to see the output. Okay, so the query produced no result because apparently it is not fetching this null value from here. So now instead of getting the total number of cases globally, I am going to say where the country region is Europe. Okay, I am going to get the total cases in the Europe. Let's execute the query. And now you can see that there are different regions for the Europe, and for each region you can see the total number of cases which are present over here. So this is the result of the query, and now I am going to convert it into a chart. So I am going to click this chart button here. And then from the different value, I think this line chart looks good. So this is the one that I'm going to select, and I'm going to go back to my dashboard. And this is the first tile having the data about the number of cases in the Europe. You can also rename it. Go to this one, view the chart. This is the chart present over here. You can rename it any way you want. I am going to call it total cases in Europe. Okay, now when I return to this, you can see that it is much more meaningful here. Now, in order to make our dashboard a bit more presentable, I am going to add a few more tiles here. So let's add the first tile. This time I am going to get the data for the vaccination. So I am going to write a query to fetch the daily vaccinations for each country. So the query is gonna be select star from, and then here I am going to nest another query. So inside the nested query, I am going to select the average of the daily vaccination as average daily and the country region. And I am going to select these two values from, let me select it once again, public dot COVID vaccinations. Okay, where date is equal to 1. Here I am going to use the date filter. This is the date filter which is already provided by the Snowflake. So all you have to do is press a colon and then select date range, date range. And once you click on the date range, you can see that this button appears over here and you have different options to search from. Either you can select any custom value, or these values I am going to select all time. Okay, then I am going to group the data on the basis of the country region. And once the data is fetched from this, I am going to order it in descending order of average daily. Okay, now let's execute this query to see the result. And you can see that it has provided me the average daily vaccinations for each of the country, and this data is in the descending order. So this means that China has the largest number of average daily vaccination as compared to all other countries. Now, if I want to display it in a visual manner, I am going to convert it into a chart. And for this type of data, I think bar chart will be the best option. So this is what it looks like. Let me change the axis a bit. I'm going to change the orientation. Okay, this looks much better. Okay, let's go back to the dashboard to see how it looks. And you can see that these are the values for the graph. Okay, I forgot to change the name. Let's go back to the dashboard, scroll down a little bit, go to this chart, and here I am going to say average daily vaccination per region. Okay, now this looks good. Okay, you can see it gives a more meaningful title. Okay, one thing I am noticing is that it is showing the average daily on both the axes. Let's change it. Go back to your tile, and from the chart type here you can see that I want the region to be on the x-axis. So in the x-axis I am going to say country region. Okay, it is changing to something. Let's change it back to average daily, and here select the country region. Okay, this looks better now. Let's go back, and you can see that now you have the region name and the average daily vaccinations for that region. Now let's add another tile. And after adding the tile, I am going to write a query that is going to display, or that is going to get the data of the number of deaths that happened in a particular region. So I am going to find the number of deaths in different states of the United States. So I'm going to write this query. Here I am selecting the province state and the sum of death values from CT_US_ COVID test, which contains the data specifically for the United States. Where date is, again I am using the filter. So it has not picked up the filter. Let me do it again. Date range. Okay, this appears here. I am going to select all time. Then I am going to group the data on the basis of province state, and I am going to order it on the number of deaths in the descending order. Moreover, I am going to limit the number of records to 5. So this means it is going to return me the top 5 provinces having the most number of deaths due to COVID. Okay, now let's execute the query to see the output. And you can see that it has provided me the top 5 states from the United States which have the most number of deaths. And out of these 5 states, New York is the state which has the most number of deaths because of the COVID-19, and Florida has the least number of deaths. Okay, so now let's convert it into a chart. So for this particular data set, I think a heat grid would be a good option because it is going to show the actual value for each state. Okay, this looks good now. Let me rename it. I am going to say per state death in US, or I can say that top 5 state death numbers in US. Okay, this looks good now. Let's go back, and you can see that it is showing us the title top 5 states death numbers in US, and it is giving us the name of the states and also the number of values for each of the state. And if you notice that it has given a darker color to the state that has the highest number of death rates, and a lighter color to Florida which has least number of deaths. So if I scroll up a bit, you can see that this is how our dashboard looks like for now. And this is how you can create different type of graphs in your dashboard using Snowsight. That's all for this video. I'll see you in the next one. Welcome back. In this video, you will learn what is time travel in Snowflake. When we talk about time travel, we would like to see how data looked like at some point in time in the past or in the history. The purpose or use case could be anything, for example, analyzing our ETL or ELT process and how it changed the data from state 1 to state 2, or restoring data that accidentally modified or updated or deleted, taking a backup from the past, and many more interesting use cases. So let's understand it in detail. We have a customer table and data is loaded via copy command, and we can say that it is day 1 and a time t1 and a version v1 data with a query id ending with 000. Next day, an ETL job performs an update operation that updated one or more rows and changed the state of the data, and we can represent it with a day d2, time t2 and version v2 with a query id ending with 111. A few more DML operations executed, and that may include insert, update, and delete SQL statement, and that's how we reaches the day 9 and the time T9 with the version V9 having a query ID ending with 999. Now, in traditional database system, it is hard to see how data looks like at version V2 or version V1, and any version or state of the data between V1 to V8 when your current state of the data is V9. However, in Snowflake, we can look back up to 90 days of historical data, and that is what we call a time travel in Snowflake. The default time travel duration is 1 day for a standard edition, and it can be set as 0. 2, if you try to change this value higher than 1 for standard edition, you will get an SQL error. The time travel duration is also known as a retention period, and this can be changed at account level using a parameter function. This parameter is known as data retention time in days. For enterprise edition and above, you can set up this value from 0 days to 90 days. Now let's elaborate this example and see what all I can do using extended SQL to leverage the time travel feature. If I just write a query select star from customer table, it picks the state of the table from version 9 and displays the result. If I want to see how data look like at version v2, then I can use extended SQL, which is not on standard SQL. And we can use time travel SQL keywords like at or before and fetch the results. So here I am writing the SQL statement select star from customer table at statement id equals to query id ending with 111, and this brings the state of the data at the version v2. So at is the keyword which allows me to fetch the historical data, and you have to pass statement id so Snowflake knows what to pull from the history. I can also use before keyword and see how data look like before version v2. And the syntax goes like this. Select star from customer before with statement ID ending with 111. And it pulls version v1 state of the table data. So this is how the overall extended SQL for time travel works. This is not the standard ANSI SQL keywords. You can use keyword offset in place of add keyword if you don't remember exact query ID. The offset allows you to go back to X seconds back in the history from your current timestamp. The syntax goes like this. Select star from customer at offset and values in seconds. In this case, I want to see how data looked like 300 seconds back, and here you can also use expressions alternatively. You can also specify the timestamp and fetch the dataset. So this is how all the different extended SQL works. So we have 3 ways to fetch the data from the history. Using time travel feature, using the statement or the query ID. The next option is that using the timestamp keyword, and the third option is using the offset keyword. And this is how they look like. You can use any of them based on the use case or your business requirement. Don't worry if they are not very clear to you. We'll see them using the free trial edition later on in this section. But that's all for this video. I'll see you in the next one. Welcome back. In this video, we are going to talk about time travel versus failsafe. Snowflake often talks about a concept called failsafe, and many Snowflake developers think that failsafe is an extension of the time travel. No, it is not. Let's understand the purpose of failsafe. The time travel can be defined for a table, and it can be 0 to 1 day for standard Snowflake edition and 0 to 90 days for enterprise edition and above. Let's take the same example where we loaded the data and we can define the state of the data as V1 on the day 1. On the day 7, we can say the state of the day is V7, and on the 97th day, we can say the state of the data is 97. So this is how it looks like. Each of this version are having a query ID, so we can always access this data through the extended SQL for this table. Assume that we have given the time travel value as 90 days. A Snowflake user can access the data for this period. And once this period is over, the data goes to fail-safe storage layer. which is fixed of 7 days for a permanent table and 0 days for transient and temporary tables. If you have to extract data from the fail-safe storage layer, you have to contact Snowflake support team, and there is no way that you can use extended SQL or any other mechanism to extract it. Failsafe's primary intent is very different from the time travel feature. Failsafe ensures historical data is protected in the event of system failure or other catastrophic event, that is a hardware failure or a security breach. Failsafe is not provided as a means of accessing historical data after the time travel retention period has ended. It is for use only by Snowflake to recover data that may have been lost or damaged due to extreme operational failure. We know Snowflake allows us to create transient and temporary tables, and we will understand how does it work with time travel feature. When we talk about temporary or transient tables, the time travel behavior is slightly different compared to the permanent tables. And we'll try to understand this with an example. So let's say we have a customer table and the table is defined as a transient or a temporary table. We have covered this concept in the previous section, and please refer to that before going towards this video. So the table version v0 where data is loaded via the copy command, then an ETL performs some update operation on a day 1 at a time t1, and this point we can access data for the last 24 hours, or we can say for the last 1 day. As you move to the next day, the next ETL operation happens. We would not be able to access version v0 as it is outside of the 24 hours window or a 1 day window for temporary or a transient table. Then further ETL operation happens, and if we reach to the 90th day, we would not be able to access any data from version v0, v1 or v2, and we would be accessing only the current date time minus 24 hours of the historical data and not beyond that window for temporary and transient table. And that is one of the biggest difference with transient or temporary table versus a permanent table. The default time travel retention period is 1 day, and if you set it to 0, then you would not be able to access any historical data for temporary and transient tables. Now let's quickly see how the fail-safe period looks like. The fail-safe period for temporary or the transient table is always 0, so it does not even change no matter whether you have a standard or a higher edition of Snowflake. Unlike permanent table where the fail-safe period is 7 days for temporary and the transient table, it is always 0. And this is done for a purpose if you are doing a lot of development activities and you don't want to retain the data because it is constantly changing, and you can create a transient table instead of creating a permanent table. Because if you create a permanent table, even if you drop the table, you still have to incur the 7 day storage cost. So this is very important fact, and it is very important to remember if you are constantly working in Snowflake. So that's all about Snowflake time travel versus failsafe. That's all for this video. I'll see you in the next one. Welcome back. In this video, you will learn how to enable time travel in Snowflake. Let's go to our Snowflake UI and let's perform some hands-on exercises using the time travel feature. So I am going to start by changing my context, and the context includes having the database name, schema, and role or warehouse, etc. So I am going to change the context by using the role account admin, using the warehouse compute underscore WH, using the database e-commerce, and then the schema e underscore dev. Let's execute all these statements, and our context has been successfully changed. Next, I am going to create a new table inside the schema called tt underscore 3 underscore days, and these are the columns present inside the table, and I am going to keep the data retention time in days to 3 days. Okay, now let's execute the Qt to create the table, and you can see that our table has been successfully created. Now let's just go ahead and describe the table that we have just created. So once you describe the table, you can see all the columns which are present inside this table, their data types and so on. But if you scroll down a little bit, you will see that it is not showing us the data retention time for this particular table. So what should I do in order to see the data retention period? If I really want to view the data retention period for a table, then I have to use the show tables command. So here I am going to use the show tables statement to show the tables like tt underscore 3 underscore days, and then I am going to execute the query. Upon execution, now if you scroll horizontally, you will see that the retention time is given and it is displaying the number of retention days to 3. Okay, so in order to view the data retention period for a particular table, you have to use the show table SQL statement. Alternatively, you can also view the data retention period for a table using the information schema. So for that, I am going to write this particular query. Here, I am going to select star from the e-commerce database dot information schema dot tables, where the table name is tt_3_days. Okay, now let's execute the query. And you can see that the information schema has also displayed the retention time to be 3. This means that the retention time for this period is 3 days. So you can use either of the two that you want. Once you have seen all the ways to fetch the data retention period, next I am going to populate this newly created table with some data. So I am going to write this query. I am going to insert the data into the table from the Snowflake sample data database table order, and I'm going to limit the number of records to 1 million. Okay, now let's execute the query. After a while, you'll see that total number of rows that we limited have been inserted into the table. Now let's quickly view this data to vary data insertion. And to do so, I am going to write this query, select start from TT3 days, limit the number of rows to 10. Let's execute it. And you can see that the data has been successfully inserted into our table. Now, before I make certain changes to this data, let me see how the min and max value of this particular table looks like. In order to find the minimum and maximum values of a particular column, I am going to use this query. Here I am selecting the minimum order key and the maximum order key from our table. Let's execute this query. And you can see that this is the value for the minimum order key and this is the value for the maximum order key. Now, once I have seen the minimum and the maximum value, next I am going to update this table. But before updating the table, let me run another query, which is going to look something like this. In this query, I am going to count the number of days that satisfy this requirement, where the requirement is order key is less than 10,000 and the order priority is 1 urgent. So the purpose of doing so is to get the number of rows, so that in the next statement where we are going to update the data on the basis of this query, we'll know how many rows should be updated. Okay, so let's run this query. Upon running, you can see that only 2 rows satisfy this condition. So when I'm going to run the next query in which I am going to update the table on the basis of this statement, only 2 rows should be updated. But these are very few rows, so let me change 10,000 to 100,000. Let's execute this again. And you can see that now I have 15 rows. So when I'm going to use this select query, 15 rows should be updated. So when I'm going to use this condition in the next query to update the data, only 15 rows should be updated. Now let's write the update query. So I'm going to use this query here. I am going to say update the table, set order priority to 1 urgent, where the O_order key is less than 100,000 and O_ priority is not equal to urgent. Okay, now let's execute this to see that updated data. And you can see that number of rows updated are 15. And if you remember that when I done this previous query, the number of rows returned was also 15. So this means that our where clause has worked correctly in this scenario. Let's go back to your query result. And in the right side, you can see that you are provided with the query ID. And you can do so by clicking these 3 dots and you will get the option copy the query ID. Now the query ID has been successfully copied. And we are getting this query ID because you know that we need the query ID in order to perform the time travel. Okay, so before moving forward, next thing I am going to do is I am going to delete a few rows from this table. And to do so, I am going to write this query. Here I am going to delete from the table all the rows that we fetched in the previous query or that we updated in the previous query, because the where clause is the same in all the 3 statements. So this delete query is going to delete those 15 rows from the table where the order ID is less than 100,000 and the order priority is not urgent. Okay, so there is a mistake. Instead of not urgent, let me say equals to urgent, because here we have updated them to urgent. Okay, so this query is going to delete all the 15 rows that we updated in the previous query. Let's execute it, and you will see that a total of 19 rows instead of 15 have been deleted. Okay, so in order to keep record of the things, let me add a few comments here. So here 15 rows were updated. This is the first comment that I am going to add to keep the record, and this was the query ID of the result. Okay, next, when I perform this particular query, a total of 19 rows were deleted. Okay, and now let's just go ahead and copy the query ID for this particular query also. Copy this, and I am going to paste it here to keep the record of the query ID. Okay. Okay, so we started with 1,000,000 rows that we inserted into the table. Then we performed an update, as a result of which 15 rows were updated. Now we have deleted 19 rows from the table. Now let's go ahead and see what is the total row count in the table, and for that I am going to write select count star from the table, and it should have 19 rows less than 1,000,000. Let's execute it to see the output, and you can see that it has given us the correct output, which means that 19 rows out of 1,000,000 have been deleted, and the remaining is these number of rows. Now let's keep track of the number of rows too. So I am going to copy this value here, and I am going to make a comment to remember the number of rows that were present at this particular query. Okay, so now we are going to actually see the functionality of the time travel feature. So I want to view the number of rows that were present before I updated or before I deleted these rows from the table. So for that, I am going to use this query. Here I am going to select count star from the table. Then in order to use the time travel feature, I am going to use the before keyword for the extended SQL, and inside the statement, you know that you have to provide the query ID. So this is the query ID that I copied from the query in which we deleted the rows from the table. Okay, so this query is going to return me the number of rows that were present before the execution of this particular query. Let's execute it to see the output, and you can see that it has returned me 1,000,000, which means that before the execution of this delete query, a total of 1,000,000 rows were present inside our table. And this shows that our time travel functioning is working properly. So you have seen the working of the before statement. Now I am going to copy this query, and I am going to change it a bit. Now instead of before, I am going to use the add keyword, and now this query is going to return me the number of rows that were present when this particular query ID executed. Let's run this query, and now you can see that when we perform the delete operation, after that a total of these number of rows were present inside the table. So the before keyword gave us the number of rows before the execution of this query ID, and the add keyword gave us the count of number of rows that were present when this query ID executed. We can also join and find the number of rows that were recorded between two particular queries. But I would not suggest you to run this join operation, because it is going to be a pretty expensive join operation. And instead of this, I would suggest you to prefer the minus operation. And in order to perform the minus operation, I am going to use this query. Here I am selecting all the records from the table before the statement having the query ID this, which is the query ID of our delete operation, and I am subtracting it from all the records that are present inside the table. So in this particular query, I am actually trying to get all those rows which were deleted when we perform this particular query, because we know that upon running this query, a total of 19 rows were deleted, but we don't know what was the data of those 19 rows. So once I execute this query, I am going to get the data of all those 19 rows which were deleted when we run the query having this particular query ID. Let's execute the query, and you can see that a total of 19 rows have been returned, and these are the rows that have been deleted once we executed the delete operation, having the order ID less than 100,000 and the order priority was urgent. Okay, so this is a way to get the data using the time travel feature. But there is another approach of doing so, and it is to use the not exist query. So in order to fetch the data with the second approach using the not exist statement, I am going to write this particular query. Here I am selecting the same data that I selected in the previous query, which is the data that occurs when we run this particular query. Then instead of minus operation, we are using the not exist statement, and outside the not exist, we are selecting all the data where the order key of the past query is equal to order key of the present query. So this query is collectively going to return us all those rows which are not present in the current scenario or the current version of the data. Okay, now let's execute the query. And you can see that once again it has returned us 19 rows, and these are the same 19 rows that were deleted when we performed the delete operation on the table. As I have already mentioned that there are 3 ways to perform the time travel. The first one is to use the before keyword, the next one is to use the at keyword, and the third one was to use the offset keyword. Now I am going to show you how the offset keyword works in order to perform time travel. Now in order to use the offset keyword, I am going to use this query. Here I am selecting count of all the rows from the table at a particular offset, which is this particular value. So it is going to give me the number of historical data that was present 300 seconds ago. Now let's execute the query, and upon execution you will see that a total of these number of rows were present inside the table before 300 seconds. Alternatively, you can also use the time-based approach to get the data at a particular interval of time. And to do so, you can write this particular query. Here I am going to select the number of rows that are present at a particular timestamp. And for the timestamp value, I am providing a value before the current time. Okay, now let's execute the query, and upon running, you can see that at that particular interval, it is showing me the number of rows to be 1,000,000. And instead of counting, you can also select star at this particular time interval, and it is going to display you all the rows that were present at a particular timestamp. Okay, so another thing that you can do is that you can also alter the table to change the number of data retention days. And if I want to change the data retention period from 3 days to 5 days, I can write this particular query. Here I am going to alter my table, and then I am going to set the number of data retention time to 5 instead of 3. Now upon executing your query, now the number of data retention period is 5 days. So if I want to see the data retention period has been updated or not, I am going to write the command show tables. And after show table, I am going to use the like keyword, and here I am going to pass my table name, which is tt_3_days. Now let's execute the query to see the updated data retention period. And if you scroll horizontally, you will see that the retention time has been updated from 3 days to 5 days. So now what will happen is that my data retention period will increase from 3 days to 5 days, and there will be no data loss. Let me show you another thing. Now if I change my retention period from 5 days back to the 2 days, then what will happen? Let's execute this query to change the retention period, and let's confirm that the retention period has been updated. Let's execute it, scroll down horizontally, and you will see that now the retention time is 2. So what will happen if I change the retention time from 5 to 2, that is I decrease the number of retention period days. So decreasing the data retention period will result in data loss, and any changes that happen during that period will not appear through the extended SQL using the time travel feature. And this is how you can enable the time travel feature in Snowflake. That's all for this video. I'll see you in the next one. Welcome back. In this video, you will learn how you can use the drop and undrop statements to perform time travel. You already know the function of a drop statement. It is used to delete any object from your database, just like in the SQL. But the undrop statement is used to restore the most recent version of a drop table, and this functionality is only available in Snowflake. Undrop relies on the Snowflake time travel feature. An object can be restored only if the object was deleted within the data retention period. Let's understand the drop and undrop functionalities first. So I am going to start by creating a table called time travel underscore undrop. Inside this table, I am going to create these columns and I am going to set the data retention time in days to 3. Let's execute it. And you can see that our table has been successfully created. Next, I am going to populate this table with a few rows, and to do so, I am going to write this query where I am inserting data into the table from the Snowflake sample database table order, and I am going to limit the number of rows to 10. Let's execute the query and you will see that a total of 100 rows have been inserted. Next, let's quickly validate the insertion by writing a query select star from time travel undrop table. Execute it and you will see that you will get a total of 100 rows that you have inserted just now. So this means that data has been successfully inserted into a newly created table. Then I am going to drop this table, and for that I am going to write the query drop table and then I am going to provide the table name. Let's execute the query. And once you execute it, you will see that your table has been successfully dropped. Now, in order to verify this, let's query this table again. And upon running, you will see that Snowflake is going to tell you that this table does not exist or is not authorized. Now, once the table has been dropped successfully, I am going to show the undrop feature of Snowflake. And to undrop a table, you simply have to write a simple query like this, in which you will have to use the keyword undrop table and then provide the name of the table which you want to undrop. Execute the query and you will see that your table has been successfully restored. And this shows that this feature is very much helpful in case you accidentally dropped an important table from your database. So you can simply use the undrop keyword to restore the newly deleted table. And this functionality is not available in any other database. So this is a very big plus point for Snowflake. But one thing to notice is that if I change my data retention period to 0, then in that case, I won't be able to execute this undrop statement. And Snowflake will give you an error that the object does not have any time retention period. So this means that if you want to use the undrop feature in Snowflake, then your table must have a data retention period greater than 0. Now if I run this query again, which says select star from the time travel undrop table, it is going to fetch me all the data that has been restored once we use the undrop statement. So this is how the undrop statement works with respect to a particular table. Now let's go ahead and see how the undrop statement works in case of a schema and in case of a database. But before that, I am going to write some commands here. These are the commands that I am going to execute. So firstly, I am going to create a dummy database called tt_db_undrop. Then I am going to create a schema inside that database. Okay, let me just use this database as well. Use database tt_db_undrop. Then I am going to create the schema inside the database. I am going to use the schema and then I am going to create a table tt_undrop having a single field inside it. Let's execute these commands. And you can see that all of the 5 commands have been successfully executed. Now let's insert some data into the table. And for that I am going to use this query. Here I am going to use the insert statement. Insert into the table name and the values are going to be these values. Let's execute the query. and you will see that 5 rows have been successfully inserted. So you can notice that here I have not defined any timetable period for this particular table. And if I do not specify the time retention period, the Snowflake automatically assigns the time travel period to 1. Now let's see how the databases look like. Let's execute the query, and you can see that you have a single database called tt_db_drop, and you can see that now the retention time for this database is 1. So we have not already defined the retention time for the database, so Snowflake automatically assigned it a value of 1 day. Now let's check this for schema as well, and for that I am going to use this query, show schemas like TT. Let's run this. You can see that we have a single schema, and the retention time for it is also automatically assigned to 1 day. Now let's view the retention time for the newly created table as well. And for that, once again, I am going to use the show tables keyword, and let's run the query to view the table. You can see that right now we have a single table called tt_undrop. It is inside the database tt_db_undrop inside the schema. And you can see that the retention time for this table is also automatically set to 1. So if you do not set the data retention period for the table, database or schema, the Snowflake will automatically assign a value of 1 day. So now I am going to view the data from this table, and for that I am going to write this query. Let's execute it to see all the data present inside the table. So you can see that these are the 5 rows that we inserted for the field 1 value. So now, in order to see the working of undrop statement with the database and schema, this time instead of dropping the table, I am going to drop my schema. For that, I am going to use this query here. I am going to use drop database and then provide the name of the database which I want to drop. Let's execute it, and you can see that our database has been successfully dropped. Now, if you refresh your databases from here, you can see that now you do not have the tt_db_undrop database. And you can also verify it by a query. So I am going to run this query again, and this time it is going to show you that it is unable to use this database because the object does not exist or the operation cannot be performed. Now let's view the schemas to see if it displays anything or not. Let's execute it, and you can see that this time it has produced no result because the schema was present inside the database and we deleted the database itself. Now let's undrop the database, and for that I am going to write this query here. Instead of drop, I am going to say undrop. Okay, let's execute it, and you can see, okay, this query is not executed. Let's run this. Let's execute the query, and you can see that our database has been successfully restored. Now, if I execute this query again, you can see that now it is showing us the schema tt_schema_undrop having a retention type of 1. So you can see that we can easily drop and undrop a table, a schema, and a database. But if any of them have a retention period of 0, then you cannot undrop a table or a database or a schema. And if you do not assign a retention period to your database, schema, or table while creation, then Snowflake will automatically assign it a value of 1 day. So that's how you can drop and undrop database, schemas, and tables. That's all for this video. I'll see you in the next one. Welcome back to another video on time travel series. In the previous videos, you have already learned what is cloning and how you can clone different type of tables in Snowflake. In this video, you are going to learn how you can use the clone keyword with reference to time travel and how it works with reference to time travel in Snowflake. Let's go to our Snowflake account, and the first thing that I'm going to do is I'm going to create a new table which is going to be called tt_before_clone. And these are all the columns that will be present inside the table, and the data retention period for this particular table is set to 3. Let's execute the query to create the table, And you can see that our table has been successfully created. The next thing I am going to do is I am going to populate this table with some rows. So for that I am going to use this query insert into tt underscore before underscore clone, and I am going to insert the data from the Snowflake sample data database, and the table is going to be orders, and I am going to limit the number of rows to 10. Okay, let's execute the query, and you can see that 100 rows have been successfully inserted into the table. Now let's quickly verify the insertion, and for that I am going to select all the data from the tt underscore before underscore clone table. Let's execute it, and after a while you will see that it has fetched all the data from the table. This means that our data has been successfully inserted into the newly created table. Now let's perform some delete, update and insert operations on this particular table and record the query ID for each of these queries. So I'm going to start by deleting some rows from this table, and for that I'm going to write this query: delete from the table where O underscore order priority is 5 low. Okay, now let's execute this query to see how many rows got deleted. Okay, so a total of 17 rows got deleted. And in order to save the query ID, click on these 3 dots here and click on copy query ID. And in order to keep a record of the query ID, let me add a comment here and add the query ID here. Okay. Now let's see how many records are left in the table, and for that I am going to write this query: select count star from the table. Let's run it, and you can see that now the table has 83 rows. So let me add a comment here saying records equal to 83. Let's move one step further. Now I am going to update some records from the table, and for that I am going to use this query: update table set O underscore order status equal to X, where the order priority is 3 median. Okay, let's execute the query, and you can see that a total of 21 rows have been updated. Let's go back and copy the query ID for it too. Go to query detail and select copy the query ID. And then once again I am going to add a comment here to keep a record of the query ID. Okay. Let's record the number of rows too. So 21 rows were updated. Okay, now let's go ahead and see that how many records are now present inside the table, and for that I am going to use this query. Let's execute it, and it should show us 83 rows. Yes, it is showing us exactly 83 rows, which means that our query is working correctly. Let's say record equals 83. So the data has been successfully updated. Now let's go ahead, and I am going to insert a few more rows into the table, and for that I am going to use this query: insert into the table, select star from Snowflake sample data orders table where the O underscore order priority is 5 low, and I am going to insert 50 rows from the table. Let's execute this query, and you can see that 50 rows have been successfully inserted into the table. Now let's go ahead and copy the query ID for this query too. Copy query ID and paste it as a comment here. Now let's see how many total records does this table have now. And for that I am going to count all the records from the table. Let's execute the query, and you can see that now there are a total of 133 rows. And I am going to write it as a comment again. Okay, so the working on the before clone table is completed. Next, I am going to create a new table called tt underscore after underscore clone using the clone keyword, and I am going to paste the query ID of this particular query with the before keyword. So the new table will have all the data present inside the tt underscore before underscore clone table before the execution of this query. Let me show you the query. So this is the query that I am going to use. It is going to say create table tt underscore after underscore clone. Then I am using the clone keyword, and it is going to be a clone of the tt underscore before underscore clone table. Then inside the before keyword, I am passing the query ID of this particular query where we inserted 50 new rows into the table. So This before keyword will ensure that this table will clone all the data from the tt underscore before underscore clone table before the execution of this statement. So before the execution of this statement, our table has a total of 83 rows. So the new table will have a total of 83 rows. Okay, let's execute the query to verify it. And after a while, you will see that our table has been successfully created. Now let's go ahead and count the number of rows which are present inside the tt underscore after underscore clone table. And for that, I am going to write this query. Let's execute it, and it should have a total of 83 rows. And yes, you can see that this table now has 83 rows because we cloned the data that was present inside the table before the execution of this query. Let's go ahead and see how the table looks like. And for that, I am going to write show tables like TT. Let's execute it. And in the results, you will see that these are the two tables that I have. TT underscore after underscore clone and TT underscore before underscore clone. And if I scroll horizontally, you will see the total number of rows which are present inside each of the table. And you can see that the retention period which was assigned to the tt underscore before clone table has been also cloned for the tt underscore after underscore clone table. Okay, so this means that when you clone a table having a certain retention period, then the retention period is also cloned for the new table. We have seen that our before clone table has a total of 133 rows, whereas the after clone table has a total of 83 rows. One thing to notice is that the time travel data is not available for the clone table. So if I execute a query like this on the before clone table with the statement, let's go upward, and this is the query that I'm going to pass as a statement. So if I pass this query inside this table, this query is going to execute successfully, and I'm using this particular query ID because it was a query at which we deleted 17 rows from the table. So if I run this statement now, it is going to give me all the records that were present before the execution of this query, which means before deleting 17 rows from the table. So the number of rows should be 100. Let's execute it to verify the data. And upon execution, you can see that a total of 100 rows are present, and these are all the rows that were present inside the table before we deleted the 17 rows. Now let's see that if we execute this statement for the tt underscore after underscore table, we would get the same data or not like the before clone table. Let's execute it, and I'm passing the same query ID for this query also. And it is giving me an error that time travel data is not available for the table tt underscore after underscore clone. The requesting time is either beyond the allowed time travel period or before the object creation time. This is because the query ID that we passed as a statement was executed before the creation of tt underscore after underscore clone table, and so the time travel data is not available for this table. So if I summarize this, the clone table does not have any history of the data of the table through which it was cloned. So you have to remember that the query ID that you passed while creating or cloning the table, only that data will be passed into the table, and the clone table will not have any time travel history or time travel data like the table from which it was created by using the clone keyword. So this is how you can use cloning with reference to the time travel. That's all for this video. I'll see you in the next one. Welcome back. In this video, you will learn how you can create standalone and dependent tree of tasks in Snowflake. Let's go to your Snowflake trial account, and the first thing that I am going to do is I am going to change my role from the sysadmin to account admin. Let's execute the query, and you will see that my role has been successfully changed. Before I go ahead to create and execute task, let me first create a new role. So I'm going to write the query create role, and I'm going to give the role the name task underscore owner. Let's execute the query, and you will see that your task has been successfully created. Once our role is created, Next, I am going to grant it access to certain objects. So firstly, I am going to grant it usage access to our warehouse, execute the query, and the access will be granted to the user. Next, I am going to grant it access to the database e-commerce underscore DB. Once you execute the query, the access will be granted to the user task owner. After that, I am going to provide it usage access to the schema e-commerce underscore live. And once I execute the query, you will see that the usage access will be granted to the role. After granting the usage access on the warehouse, database and schema, next I am going to grant select access to the e-commerce underscore live dot line item table to the role task owner that we just created. And similarly, I am also going to grant select access to the e-commerce underscore live dot orders table to the task owner. Execute these two queries together and both the access will be granted to the new role. After doing all of this, next I am going to provide the permission to create task on the schema e-commerce underscore live to the new role task owner that we just created. This is being done to ensure that the new role task owner has the permission to create different tasks on the schema e-commerce underscore live. After providing it permission to create task on the schema, next I am going to grant it permission to execute task on the schema as well. Once this is done, next I am going to grant it the ownership to all the tasks that I created on the schema e-commerce underscore live to the role task owner that we just created. Let's execute the query and it is causing me an error. Okay, so there is a problem. Grant ownership on all tasks in schema e-commerce underscore db dot e-commerce underscore live. Now run it again. And yes, now both the statements executed successfully. Let's move one step further. And now I am going to grant table creation access inside the schema to the role task owner that we just created. After providing all of the above mentioned permissions to the new role task owner, next I am going to grant this role to a user that I created for myself, which is Aliza1. And then I am going to switch my role to the task owner to perform further operations. So up till now, we have created a new role and we have provided it permission to access all the databases, tables and schema. After doing all of this, let's move one step further, and now I am going to create two new tables using the role that we have just created. So the first table that I am going to create is called daily aggregated summary, and the second table that I am going to create is called orders by ship mode. And you can see all the columns that I am going to create inside each of the two tables. Let's execute both these queries together and you will see that both tables will be created. I have created these two tables in order to store the results of the SQL, which will be triggered from within the task that we are going to create now. So everything that we have done so far are the prerequisites of creating the task. Now I am going to actually create the task. I am going to call it task daily sales summary. And inside this task, you have to provide a few parameters. First thing is that you have to provide the warehouse name, and the warehouse that I am going to use is product underscore Excel. Next, we have to provide a schedule for the task at which it will be triggered. So I am going to provide it a value that it should be triggered every day at 8 a.m. according to the UTC time. Then after the keyword as, the most important thing of the task comes, which is the SQL statement that needs to be executed. So for the query part, I am going to use a nested query. In the outer query, I am going to insert some data into the table that we just created, which is called the daily aggregated summary, and the data is going to be inserted using a select statement that I am going to write now. So for the inner query, I am going to calculate the sum of few values from a particular table. So for the first value, I am going to calculate the sum of L underscore quantity, and I am going to call it sum quantity. After that, I am going to calculate the sum of L underscore extended price, and I am going to call it total base price. After that, I am going to calculate the total discount price, for which I am going to calculate the sum of L underscore extended price, and I am going to multiply it by 1 minus L underscore discount price, and this is going to give me the total discount price. After that, I am going to calculate the total charge, and for that I'll apply a formula. Firstly, I am going to calculate the sum of L underscore extended price multiplied by 1 minus L underscore discount into 1 minus L underscore tax, and this will be the total charge for the particular order. Then I am going to count all the records from the table, and I am going to call it count order, which is going to give me the total number of orders present inside the table. After doing so, I am going to select a few more columns from the table. Firstly, I am going to convert L underscore ship date to the date format, and I am going to call it ship date in the output that is going to be displayed. And the last column that I am going to select is L underscore mode, and I am going to call it shipped mode. And all of these columns will be selected from the table line item which is present inside the schema e-commerce underscore live. And all of these columns will be selected for the record where shipped underscore date is 17th July and the year is 1996. And then finally, I am going to group the data on the basis of shipped underscore date and shipped underscore mode. Let me summarize it. So when the task daily sales summary is going to be triggered, then the sum of quantity, total base price, total discount price, total charge, order count, ship date, and ship mode will be selected from the table line item present inside the schema e-commerce underscore live, and all of these columns will be inserted into the daily aggregated summary table. Now let's go ahead and execute this query, and upon execution you will see that task has been successfully created. Now let's go ahead and validate the creation of the task, and for that I am going to write the query show task, and it is going to display me all the tasks available. Upon executing the query, you will see that there is a single task present called task daily sales summary, having task ID, database name, database schema, owner, warehouse, schedule, state, definition. And if you notice, the state of the task is suspended. So this means that currently our task is suspended and it is not running, so we need to resume the task by changing our task. And this can be done by simply using the resume keyword. So I am going to write the query alter task. After that I am going to provide the name of my task, which is task daily sales summary, and then I am going to use the resume keyword. Then simply execute the query and you will see that your task will be resumed. Let's verify this by running the show task command again. So I am going to copy it and paste it and run it again, and upon executing the query you will see that now the state of the task has been changed from suspended to started. So now the task is going to start at 8 AM UTC time every day. And that's how you can create a simple standalone task. Now I'm going to create dependent task. So let's create a second task which is going to be dependent on the first one, and I'm going to write the query create task, and the name of my task is going to be task orders by ship mode. And then I am going to go back to my previous task, which is the task daily sales summary, and I am going to copy few statements from it and paste it in the new task. Since this task is going to get the data from the table daily aggregated summary which we created in the task daily sales summary, so this task must execute after the task which is called daily sales summary. So I am going to define it by using the after keyword and providing the name of the task. Then, as explained earlier, after the as keyword, I am going to define the query that needs to be executed when the task is triggered. So I am going to write the query insert into e-commerce db.ecommerce underscore live orders by ship mode table, and data inside this table will come from within another query which I am going to say select and then I am going to pass a few values, which is going to be the rounded value of the sum of. Then I am going to select the rounded off value for the sum of total discount price, and I am going to call it total discount. Then I am going to select ship date and ship mode from the daily aggregated summary table that we created in the previous task. So let's just go ahead and execute the query, and you will see that it is saying unable to update graph with root task e-commerce underscore live dot task sales summary says that root task is not suspended. It means that when you create a task that is dependent on another task, then you have to ensure that the parent task is suspended at the time of creation of the dependent task. So all I have to do is change the state of the parent task from resume to suspended. So let's go ahead, and I'm going to change the state from resume to suspend. Then simply execute the query to change the state of the task to suspended. So once this is done, now let's go ahead and rerun your dependent task to see if it is created. And yeah, it is created successfully. Let's go ahead and view the task once again to see the data and the state of both the tasks that we created. Then simply execute the query, and you will see that now we have two tasks, and if you scroll horizontally, you will see that there is no schedule for the dependent task. This is because it is going to be triggered after the execution of the parent task. Then you can see that we have predecessor for the dependent task, which means that it depends on the parent task. Now the state of both the task is suspended. So now in order to run the task, I have to change its state from suspended to resume. So I am simply going to run the alter task statement again, and I am going to change the state of both the tasks from suspended to resume. Now let's execute the first query, and you will see that our task has been successfully resumed. Let's resume the second task now, execute it, and I'm getting an error because the first task is not suspended. Okay, now go back to your first statement and change the status from the resume to suspend. Execute the query so that our parent task is suspended. And once this is done, then I'm going to go ahead and execute my dependent task to change its state to resume. And once I do this, now it is successfully resumed. And once the dependent task is resumed, go ahead and use the alter task statement again to change the status of the parent task from the suspended back to the resume status. Go ahead and simply execute your query to change the status. Now I am going to run the show tasks statement again, and upon execution you will see that now I have two tasks, and if I scroll horizontally you will see that the state of both the tasks is started. And this is how you can create standalone and dependent trees of tasks in Snowflake. That's all for this video. I'll see you in the next one.